Good evening, folks. Welcome to the Greg J. Show. Night Owls.
The Iron Dome. That's all I'm going to say.
I don't care about any Iron Dome. I don't trust that guy as far as I can.
I hope you enjoyed the show.
Anyways, yeah, the void. Yeah, it's huge. It's massive, and that's not the only one. There's many of them.
How many light years do you reckon that might be?
Well, they actually have it on.
Oh, 6 to 10 billion light years.
See?
Okay.
Billions. Okay.
1 billion light years across.
Can't even fathom that.
I don't know. I don't think that the distances are as far away as they say.
Well,
Because even
you have to look at them.
Well, you could
not
be
a very
what we could very well be looking at is the spaces in between two Birkeland currents, massive Birkeland currents.
Yeah.
So,
that you can't see. They're like,
Because I think it's all fractal. I think it's all fractal.
where does that mean?
It's just the same
It is
thing.
fractal.
Are humans fractal?
Same thing happening, just in a gets smaller and smaller, or you can.
I get it. Yeah.
Follows the Lichtenberg pattern, the same as the space does.
Lichtenberg, yeah.
Yeah, I always say that wrong.
But I found that some of these events or things that happen electrically present slightly differently on different scales.
I'll agree. Yeah, sure.
And that's the reason why the mainstream science community can't wrap their heads around the electric universe, because we say that electricity happens on all scales, and everything looks different to them.
I believe it was Hannes Alfvén, and his quote was, the gravitational systems are the ashes of prior electrical systems.
Yes, that's what I meant to
There
say.
you go.
I don't know why I memorized everything.
That was in a nutshell. This is me in a nutshell.
And I think it was Wald that said magnetism is the ashes of the electrical force as well.
A byproduct.
Yeah.
Well, in a way, he's right. I mean, we can, just by taking a battery and running a copper wire through it, and then putting two pieces of metal together, and then just tapping the end of that 12-volt battery, they're magnetically glued together now.
What do you think of the magnetic universe people who say that electricity comes from magnetism and everything?
They're right too.
Well, they're partly right, but
But
they're not. But they're not correct in reasoning why there are so many magnetic fields out there. They think that these magnetic fields are generated by static, in these dust clouds, all these particles rubbing up against each other and creating a magnetic field. That's not the case.
But that's just taking the example of
if they could see
thunderstorms work.
If they could see the Birkeland current and the flow and the counterflows and all of that going on, generating a hell of a lot more electricity, cooler water, and when you're at night, in cooler water, and they would see that these magnetic fields are being generated by these Birkeland currents, not by any static electric motion of these gas clouds.
Yeah.
And
Well, that's what
You
Alphane's
see areas
paper
of space that have
1986.
no gas in them that have these magnetic fields. Sorry, go ahead, Neil.
I was simply going to say that's exactly what Hans Alphane was talking about in his paper in 1986 that I was citing there in that picture. So I'll just give it to you there, Greg.
Yeah, put it in chat and I'll show it.
There you go. And that's just what he was basically saying. There it is. Yeah. And not basically what he was saying, exactly what he was saying. This is his paper. This is from the NASA server, as you can see. And it was from May 1986, I think. And you could skip through and just see where he's basically saying, don't do this, I was wrong, don't do this, that's not real. Everything that he
got his Nobel Prize for, he said, don't use it.
Well, not everything, but yes.
That's amazing. That's amazing.
Why?
Because he was wrong. He said
because he saw the light. He understood how
he made a simple mistake. His simple mistake was saying that space is superconductive, plasma is superconductive. And once we started using it on Earth in the 50s, we realized, oh, it isn't. But they never changed astrophysics. So that's why we have their version of electricity called magnetohydrodynamics, which is not what they should be studying. If you want to know how
static electricity.
Well, if you want to know how interactions between, say, Jupiter and Io work, study electrical engineering.
Mm-hmm.
And then imagine and start ripping surface off of a metal ball, and you're going to see a cliff.
Discharge from from the Purple Dawn drama.
Pardon?
What was that about the Purple Dawn drama?
That's the last remnant. With what Jupiter and Io were doing are the last remnant of everything that was taking place at one time like crazy.
Yeah, that would probably be the last connection that there was, because it's still going on now.
Yeah.
That's interesting.
I mean, you can see they actually, in the pictures of Io, when they're showing you pictures of it, because they flew a spacecraft near it, they had to color. I'm not kidding. And call it lava, because it was so bright, it was flooding the sensors. It was an arc reaction melting that. It's a mile-high canyon.
Yeah, they were calling it a cryovolcano.
Yeah. And I'm like, guys, what the heck? Because it's so cold.
Yeah, because it's so freaking cold, and
I'm like,
especially in its atmosphere.
They think there's ice in the center of the Ceres crater because they saw white light. No. That's an arc.
Well, they thought it was reflective light, right?
Yeah.
Right.
Jeez.
But they're not trained in it. But to me, it's obvious. Anyone who studied like blowing things up with electricity and watching them just fly apart, or ripping the surface off of materials, or blowing, or just get zapped by a CRT monitor and watch the shape of the craters that are formed in the dust, knows what we're talking about. This is naturally the way it works. I mean, one thing that you could know, you ever do this? This is for everyone here, okay? Have you ever looked at a sci-fi movie and they're bringing you down to a planet with craters on it, right? And you immediately go, that's not real. And you don't know why. Because there's a pattern. There is a pattern. When you look at craters on a surface that is like the moon or Mars or something, you see craters, but you see small craters on the rims of large craters. That has to happen. And if it's not happened you think it's fake. And that's what it is. Your brain knows it's not correct. And I've seen that many times. But if you look at any picture of the moon or the Mars at all, you will see that they are clearly electric hits. Because they have to be... Sorry, go ahead.
What was that first movie that had them being shot to the moon through a cannon?
That was 1902, and it was called Trip to the Moon.
You take a look at the picture that they drew of the moon there, you could tell it's fake.
Well, obviously.
Well, they also put a man's face in it.
I thought it was real too.
No, but if they would have put craters on top of
Well-
craters, then it would have looked more realistic, is what Neil's saying.
You would have noticed it, but any picture of the moon or anything like that, you will see clearly the craters. Like there would be a crater and a small crater. You never find like a large crater on top of a smaller crater rim or anything.
And you
like that.
you see the exact same thing in microscopically looking at
Yes.
electric machine discharge or discharge machine.
In fact, that's what they use to make the mirrors that these telescopes are made of.
Here's a
But the-
NASA tidbit that you might find extremely interesting. In around 1929, the Nazis made a propaganda film of a giant rocket that moved really slow on a great crawler. Everything that NASA did with the rocket on the Caterpillar and the guys in their suits getting out and going up to the rocket and then having the dramatic 10, 9, 8, 7 countdown. We thought that was pretty original. No, it was created by a movie maker named Fritz something or other. It's right there on your screen. And it looks like NASA took their book right from his scene, almost. He has the astronauts laying down. You know, it's pretty crazy that that whole thing was contrived by the Nazis before they were the Nazis.
Well,
Well, I'm not remotely worried about that because I
There-
know that they went to the moon.
well, considering that
And I'm
a
going to
lot
tell.
of,
I can
a lot of
describe it to
Nazi
you why.
engineers came
Right.
from Germany to NASA. That makes perfect sense.
Yeah.
But
Germany
one of the things that you can easily tell, because there are certain things that you could only do in vacuum, and they were not copied in any other film since, like since even Capricorn 9, which was a movie hit of the day, didn't do things correctly.
What was the name of that movie?
Which one?
The one you were just talking about, the German?
Yeah, all I know is this Germany's, there's a name for it, but I can't remember. Moon Mission movie. I'm going to run it on YouTube and see what I
Nazi
come
moon mission movie would probably find it.
First
up. Nazi
woman in the
Mission
moon.
movie, yeah.
Although I do happen to have Iron Skies where they shows Nazis on the moon and they come to attack Earth. It's great. 2016.
Yeah, Iron
I've seen
Sky.
it.
Hilarious.
I've seen it.
You'll probably get a whole bunch of hits for that
I
one.
think my favorite part was that one where he goes, and the patriotic short film made by Charlie Chaplin. I'm like, wow. You
So,
know, like
so what day did this? What's the
46.
date of this? 1946.
I'm trying to, I saw it only once, and that was a long time ago. I recorded it, but I don't have it anymore.
well, if it exists, I'll find it sometime for you.
Yes, I will find it. and put
I could do it. It's no problem.
But there's a whole scene. It's in a movie. It's really crazy.
Well, if it's in a movie,
Yeah. See if they showed it.
oh,
I'll have to find it.
I found it.
Found it?
well,
Oh,
you're
that-
asking a guy who knows how to find things. Okay, certain words only go certain places. That may or may not be what you're looking for. Okay, that's not the screen. I didn't.
That's a
We've lost you,
a
Jim.
recopy. That's a recopy of the last post.
I
you
just
did.
put one in. That may or may not be it. Try it.
Okay, NASA government. No, I'm just getting this thing this abstract from Hans Elfane.
No, you just never clicked it.
Okay,
German,
hold on.
Japanese,
Scroll down and click it.
1945.
That one.
Yeah.
The bottom one. The bottom one. Trust me.
The bottom one that I'm on right now, right?
Oh shit.
Yeah, that's why I said you doubled up, dude.
I screwed up. I
Yeah,
thought, okay, my bad. And now I have to go find it again. Well, I'm looking
I,
at history.
I tried to tell you you doubled
Look,
up and
I
you
thought
said,
you were
"Wait,
talking.
no,
I'm talking to. I thought you were talking to him.
Is it a documentary?
yeah.
Okay, it's a half a century of the German moon base and German-Japanese flight to the moon.
I think he was looking for a propaganda film. That's why
Yeah.
I
Well,
specifically
this
looked
is
for
this
it.
is this
Check
thing was
this
made
out.
in 1945, according to the
Yeah.
authors of the underground German documentary movie from the Thule Society.
He
Yeah.
said it had a lot of
The only
in
produced
it,
craft
like a
of the
lot of propaganda music. So I thought
diameter neighbors.
that's it. Or
Carrying it down to the launch pad, just like they did in the NASA. It was exactly like that.
And
I'll have
they
to.
and they launched.
sorry,
it
I
in the
apologize if I didn't
V2
find the right
rockets.
one, but it looked like it was a right.
Yeah, that did. It looked very good. I'll find it and I'll
Okay.
share it with you guys when I do, because I don't want to waste too much more time talking about it. So,
Oh my God! I
what
could have
else?
done it. Astro Command, please.
What else you got there, Greg?
Well, there was a subject that's got me.
Than cooler water,
Clearly.
and when you're at night, evaporation almost ceases. The only thing that if there's a wind, it'll help evaporation, help pick up, break the bonds, and it's not that it breaks up the hydrogen and oxygen bonds.
No, obviously not.
It just
nuclear wind would be kind of crazy.
It just turns the liquid into a gas, probably by friction, by wind blowing across it. Somehow, I'm guessing.
What causes the water to become weightless? Because I think in there is the secret to anti-gravity. It loses an electron or a proton or something.
Well, it could be charge. Could be as simple as charge.
We know charge is, for example, that's something that happens just before dawn in many swampy places. The charge can be seen as fog. And fog is almost always, if I'm being bold, almost always sort of like a electrical phenomenon. It's not a powerful one. It's just enough, just kind of like when there's quote unquote an atmosphere on the moon. It's not, obviously. It's just the levitation of dust particles, because they too would be surrounded by, if it's a positive, it will be surrounded by negative and pushed apart, and then eventually it begins to create a small atmosphere.
Correct me if I'm wrong, but on the sun side of a planet, any planet, it's more highly charged than the shadows side of a planet.
That is correct.
And the transition zone would be where charges are going crazy, haywire, in changing. I don't think polarity, but just the amount of charge.
Well, it's not a polarity change. It's basically like if anything that has, like, basically there has to be something to form this around. Like dust just forms around. Any sort of dust in the atmosphere will cause water to accumulate on it, and that's where it all starts coming together.
Roger that. That's part of the standard model too.
Well,
so,
yes, it's not.
Yeah.
There's nothing. There's nothing.
There's a lot of good in the standard models out there.
Well, obviously, yes. We made cloud chambers. We know what we were talking about. They just didn't imagine trying to put this on such a scale. Where you're going to.
Yeah, planetary scale.
Even when water evaporates from the salt water, it leaves the salt. So that's how we keep fresh water.
Yes. Correct. 100%.
Why doesn't it fall like all at once instead of just raindrops? What causes it to have?
You would have to ask Gerald Pollard that.
No, I can tell you why it doesn't fall all at once. That's easy.
Why is that?
Surface tension.
Surface tension.
It's not even unlike the principles of electricity, where it basically wants to form into tubes to transmit itself from point A to point B. It lowers its
Or
cross section.
cells. Yeah.
Yeah, or cells. In this case, surface tension will not allow a giant ball to fall. The wind would break it up into smaller droplets. Just that alone. And then because the water coming down is not incredibly, like, it's not going to be subjected to the same forces that, like, I mean, it's being pulled up and it goes up into and gets cold. That's true. And turns to ice and falls back down as hail. Yes, that is all true. The fact that it gets cold, though, is very interesting. I mean, it depends on how high it goes, how cold things get.
Yeah.
But-
Well, it's basically thermal. It's going through different thermal layers of the atmosphere, and the higher you get, the colder it gets, and the higher the and wind currents obviously have a large portion of the play. But Gerald Pollard says that the rain is not falling from the ground, from the sky. It's being pulled.
Yes, in
To
some
the
cases
ground.
it is.
Yeah. Now, is the fact that it's colder when we get higher toward the stratosphere, is that because there are much less oxygen atoms? They
Well,
get thinner. They get thinner and
it
thinner,
does get
right?
thinner, and the inability for it to affect you becomes evident. Like,
Yeah.
I mean, you can be in the thermosphere at, say, like very high up, and it's supposed to be 1,500 degrees, but you won't feel it because the amount of material there to hit you, to transfer energy, they're going very fast because they're very hot.
Yeah.
But the amount that can hit you is nothing. That's why when you go to the bottom of the Grand Canyon, you can get heat stroke very quickly because the air is like very thick. So you have more atmosphere, so more is touching you, more pressure.
Mhm.
If it's thinner pressure, there's less things touching you. But my thoughts are, when it comes to, and I don't want to misrepresent Andy on this, is if you continue, basically, he understood that the thermal action is random. And it's true, it is, but electrical action is not random. So when it starts spinning like that, it's following the electric field lines, magnetic field lines. It's not traveling like heat would. So it gives no energy to you. So everything is very cold. If I turned on an electric field that was pulling the air in one direction, okay, it wouldn't hit you. It would go around you. It'd be following the magnetic field lines. So since it's not actually transferring any of the random heat energy to you, the temperature of it doesn't transfer to you. So you get cold. I would assume that would have something to do with what happens in a thunderstorm because it's spinning electrically.
I was about to ask. Lightning is said to be cold fire. So is it cold where lightning strikes? I mean, where it originates?
Hell no. Lightning
Is it
is
cold?
Extremely hot.
extremely
cold?
hot plasma.
I thought it would be a hot front meeting a cold front would cause.
No. When we're talking about electric wind, we're talking about something that is like spinning. But what you're describing is an arc, and an arc is a thermal breakdown. The inability of the atmosphere to resist the voltage between the 2 points, wherever it started and at the bottom where it touched. The difference in voltage between those 2 points is ramped up because of the spinning action. So you get what's called a transformer effect. Spinning electrons create a magnetic field.
Always between the ground and sky and ground. Always.
Not necessarily. There is an exception to that rule, and they are volcanoes. Volcanoes can come off of the volcano and hit the ground nearby, but that's still rare.
Right.
Yeah, I wasn't trying to completely deny you on that. I was just like,
Oh, you mean ground to ground lightning?
Yeah, coming out of
Yeah.
a volcano, but basically what's really coming out of the charged magma and dust.
We know that happened in ancient times because of the ancient Aborigines saying that the rainbow snake came out of the ground where there's a diamond mine and 150 miles away went back into the ground.
Yes.
And there's another diamond mine there.
But what you're describing are loops. They're prominences that would be on the Earth.
Yeah. There's still arc charges. There's still like light.
Oh, no, I'm not arguing with you. I'm just saying, to give a better mental example, they are not unlike prominences, or a smaller version would be like, I don't think it's tent rocks. It's that place with all the arches.
Well, I would say
Valley or something?
They're more akin to the arcs that we see on the sun when a CME goes off. You see,
well, that's what I was trying to say, like a prominence.
This prominence or this band that reforms and then shrinks back down to the sun's surface. CMEs are all charged, man. It's all plasma and electrical charge.
Yeah, and they arrive all kinds of times that we don't even really know.
Well, no, it's I think that the bands, just like the bands on Saturn and the bands on Earth, represent something. Like the bands on Jupiter, the bands on the Sun, these are of different voltages, and that makes sense because the voltage coming in at the poles is different than the voltage going out along the ecliptic, and that is the basis of a homopolar motor.
Right, I've heard that before.
Yeah, and the only difference is because it's an inefficient one because spheres are not disks.
And the same reason a galaxy is 90 degrees sitting on its filament on the cosmic web.
Oh, yes.
They're basically homopolar motors.
Well, that's if they're a primary one, and what I mean by a primary one would be something like Sirius.
And they're following the right-hand rule, too.
You're correct, yes. But Sirius, for example, is in the middle, like the Pleiades, is in the middle of our local chimney. So let's call that the middle of the Birkeland current. We are sitting on the side, attached to the side of the Birkeland current. We're like stuck to it. And we have a field around it. We're going around the Birkeland current. Okay.
Yeah, we're within one of the tubes.
No, we're just beside it. We're touching it. We're getting our power, clearly getting our power from it. And Proxima Centauri gets its power from us.
Is that right?
Well, it's not directly, but there's layers. There's layers on the edge of the tube.
You think a portion of the Birkeland current is broken off and then attached to the sun?
No. I don't think it works that way exactly. I think that we're between two layers. We can see the tube layer inward because it is stronger than the tube layer outward, and we're between those two layers. And then I think Proxima Centauri, which is even dimmer,
that's what
between two layers.
We're within the Birkeland current
sorry, I meant
layers.
I said what I should have said is local chimney, because that's what they think. That's what they call it. They call the Birkeland current the local chimney, the tube. But I think there is some extra ones on the side that give us a voltage differential that we can't see because we know that these things travel in layers. This explains why the Pleiades in the middle exploded, and that's why Sirius is in the middle, is very bright, the brightest star in the sky, actually.
Right.
Like it is Sirius. It's the Eastern Star. We see it. It's just what it is.
Yeah.
And it's very powerful.
But that's it. Pretty good. Yeah, well, so anyways, I was talking about that with the weightless thing because it occurred to me that when someone figured out the process of how that happens, they have a roadmap to how to build electrogravitics. You just follow what happens to water.
Well, the trouble is that the idea of gravitics being unrelated to electricity is the mistake that I think that
No,
we
it has
made.
to be. It's just like water.
Well, no.
Yeah.
You know, got to understand their point of view. Everything from their point of view, basically all of the information that we have and everything is because of the bending of space and time.
Mm-hmm.
And there's no way to merge that with electricity. But if Wall Thornhill was correct. No, space-time can't be bent, I don't think. I think that we live in a Cartesian universe, and mathematics has gone off the deep end,
Agreed.
in my opinion. I think that, and not to disrespect the individuals, because each individual is doing great science, and they're doing the best they can with what they have.
Mm-hmm.
But that doesn't make it correct. That's just the only reason that they're allowed to do it is because even though they've been proven wrong time and time again and refuse to say no or refuse to accept the no,
their models.
they have to readjust their models and make a little tweak. And this has led to epicycle after epicycle of additions that have led to dividing by zero, believing that Doppler effects or redshift equals distance. That makes bending of light something that is true. Well, light does bend. That is very
They're just trying to enforce their standard models of cosmology that are completely
it's only because
broken
they
now.
worship Einstein.
Right. Yep.
I think that the great thing about this the process is that you got to keep saying no, it doesn't work that way. Like, this is very simple. I mean, the rules of gravity and the rules of EM are related, I think, as Faraday expressed, that the link between magnetism and induction, which is a atomic versus macro force, atomic versus is a magnet. Macro would be amps going through a circuit.
Dielectric?
What?
What is dielectric?
Dielectric is something that you put between something that will not allow electricity to go through it.
Okay.
But, like, for example, mica is a dielectric, but it allows thermal energy to go through.
Okay.
Diamagnetic.
Or, sorry. Yes, that's correct. Yeah. No, that's right. I was right the first time. So yeah, so that's
and diamagnetic is a different thing. It has to do with magnetic poles.
Yeah,
and that's what
that's like water
gravity is, and I believe the same thing because we've seen pictures and video of people applying positive charge to objects and they levitate. And that's how it's done. I'm pretty sure that's how T. Townsend Brown did it as a student of Tesla.
I've watched.
You can bet your buns that Tesla was working on it too.
Look at if you want to learn something about this, Greg, I recommend to you and your viewers Eric Lathwaite. He had a bunch of videos from the late 1960s, early 1970s. It's Lathwaite with an E at the end.
Yeah.
Just leave it for me in Discord.
Oh, sure.
Yeah.
I'll actually just find you a nice little link that will get people started. It was my favorite, and it showed people. In fact, you might want to show them, to get people interested in them again.
And there was a young Russian fella that put some videos on YouTube, and his craft would levitate as soon as he flicked the switch.
Oh, is that right?
Now, this is by the BBC, though, so this is not something that you're going to see controversy, even though he did manage to get himself kicked out, even though he was an engineer, and he is the inventor of the electromagnetic floating vehicles, electromagnetic propulsion.
Yeah.
You mean
magnetic trains?
Yes.
Magnetic
trains.
Maglev.
He put,
guns.
It's amazing that he invented that in Britain and they don't have them.
Berkman created it. Yeah.
No, he didn't.
He didn't?
No.
I thought Berkman created the electromagnetic gun.
Oh, electromagnetic gun?
Yeah.
No. In fact, I would assume that the first person to actually invent an electromagnetic gun would never have been named. They didn't know what they did. Like, I mean, you basically have two straight lines of wire and a tube between them, like say a bamboo from the 1600s or 1800s or whatever.
Yeah.
And then you just turn it on with a battery and watch it go flying at the end. Now that effect is Ampere's law. It's not I mean, people would be doing it already. I'm sure Ampere himself must have done it. You know, to just see once you put it there and watch it go flying, you're like, huh. You know what I mean? But I mean, it wouldn't be
In
technically
1917,
a gun.
Real gun, right here.
In 1917, a French dude in André Louis Octave
Yes, but notice the words are.
created the first railgun.
But what I mean is that's an actual rail gun, okay? But I could make in my laboratory in the middle of the 1800s the principles for one. It just wouldn't go so fast as be called a gun. It would go and fire the BB gun would or the BB or whatever I used.
It would roll down the track.
No, I don't think it would roll. It would go flying, but not enough to like make me think I could make a weapon out of this. But that is technically all a railgun is. Just that's a real one made for war. So technically, I agree with you.
He made something that could create fertilizer, made him some money. I thought it was a railgun.
Well, electricity can do that for them.
Yeah.
So the videos that I have, a lot of them are, that's a good one right there. The shaping things to come. I just put that in there.
Shaping things to come.
Shaping. Where? Yeah. In the chat for the call.
Oh.
Yeah. There was, there's also one about, he has like basically a whole slew of ideas, the circle of magnetism and stuff like that. I'm going to just see if I could find the exact one with him.
No, electromagnetic kina.
Yes. So this is the guy. This is him showing how to make things. This is 1975.
It's up, right?
Sure. Yeah, he's using electricity to levitate things.
Oh, here, you want to take screen over? Are you showing it?
No. I think that the first one, just showing parts of the first one, would give you because it's basically showing all of the misconceptions down the line. It's a history lesson in magnetic engine design. It's showing you from the very beginning of basically every single motor in the entire world that's electric is based off the principle that the very first guy, Faraday, came up with, which was called the homopolar motor. And all of this is just to try to make that motor better. And, well, you can see where we are now, but I hope you see the video. You can just pop it up there.
I will. I'll put it.
I thought you could just click it.
Oh, you got it in Discord?
No, I put it right there in the chat.
No, it's in Skype chat. Just
all
click
right,
on the chat and
I'll do that right now.
Right there.
Okay. There's other ones that actually show him making things that float. Yeah, that's the first one. Yeah.
Oh, yeah, I remember this guy.
Yes, he's brilliant. Yeah. Very, very straightforward.
He's got a lot of.
Yeah.
Make it wide there so we can.
Okay.
Yeah, just there you go.
Is it okay that we watch this on YouTube?
If you wish, certainly. I would gladly show this to anybody who wants to know how we've learned what we've learned so far, up until 1972, I guess.
Maybe turn it down just slightly.
Well, wait till he talks and find out, I'm sure.
Oh, you can tell it's loud.
I think it's loud too. Right?
As an engineer, or indeed any kind of scientist,
there we go.
It's a good idea sometimes to sit down.
I just hope that I can show this on YouTube and not get a strike.
To see whether they have anything to do.
Oh, it's
with
the BBC. I don't think they strike you.
At first they may not.
BBC might be tough.
Teapot, for example.
I can play the audio. I'll just have to show pictures.
And is it the best shape for a teapot?
Yeah, just turn the audio off.
Well, I'd like to show you the first teapot
we can
that was ever designed.
Yeah, we can listen.
You may think it was centuries old,
I can just kill the video.
but it isn't. It was designed in 1971.
That is
I was
half
just
a
add the
century old.
link.
Gorgeous.
Yeah, I think maybe I.
That's one affair.
We'll see.
Why do I say this is the first teapot ever to be designed? Well, let's look again at our old-fashioned teapot and see how we can criticize it. First of all, it holds a mass of tea, and the center of gravity of that mass is anywhere but near your hand, so all the time you're fighting against gravity. Then, if it had been a large teapot, I would have to put my finger under the spout, in fact, to hold the weight at all. You've probably seen ladies do this in large canteens. Then you tend to scald your finger. When it pours with an irregular, floppy sort of flow we call turbulent flow. So let's look at our modern teapot and see whether this behaves in a similar way. Well, first of all, as soon as you pick it up, you realize that the center of gravity is going to be underneath your hand, whether it's in the unpouring position or the pouring position. And when it pours with a nice, pleasant, smooth flow. Whether you pour slowly or whether you really heave it up like that, it still pours nicely. Your first reaction when you pour rapidly like that is to want to put your thumb on the lid to stop it from falling out. But of course it's not going to fall out because it was designed not to.
Okay, well, we'll just watch a little bit of this one. Was there a point you wanted to get to with this one?
Oh, certainly, yes. I didn't want you to go through the teapot thing, but you said, can we watch this whole thing? And I was like,
Yeah.
okay. I wasn't going to argue. How about I'll just quickly look here at the at this one.
Give them a timestamp. Yeah.
Yeah, that's what I'm going to do here. Shaping things to come. Okay. Okay. So about the flow. Now, basically goes over all the motors, and I would go to, let's go to 934-ish. Go with that, maybe? That would be a good idea.
You'll find that we have done just that. Straight line propulsion. Man has thought himself superior to nature because he invented the wheel. And the wheel has certainly dominated his thinking in engineering through the centuries. But here is motion without a wheel in sight, linear motion. And there's a bonus to be had. If I increase the current to this machine, then I get lift as well as propulsion. And when I let go of the sheet, it simply flies through the air. Propulsion without wheels and without physical contact. Now,
Which is
there are
pretty
all sorts
impressive for
interesting
1970.
possibilities for this
It's
kind
magic.
of motion.
Right.
Here's one of them.
Do you want me to keep going?
Martian
Or?
war machine.
Oh, this is what I
inspired by
wanted to see.
H.G. Wells's War
Okay.
of the Worlds. When switched on, this machine will levitate itself above this aluminium sheet and also propel itself along. Switch on.
Looks like a vacuum cleaner.
But there's nothing under. I'm sure they added the sound.
Yeah.
Nice heaven crap.
This, if you understand this, you understand that unlike gravity, this is generating heat.
Perhaps that's a bit way out at present, maybe the year 2000. But what is concerning us seriously at
Yes,
this
it-
time is the possibility of
Well, yeah,
using the same
you
idea
have to fight
but
gravity. You
for
can't do that without heat.
guidance along a track.
The
For
50-50
the
power
possibility
ratio.
of high-speed travel. So let's now look at a levitation system which is only allowed to move in one direction. When this aluminium plate is
You can
lifted
skip-
over this coil system,
You could skip most of this.
you'll be seen to be free to move
because
in this
he actually-
direction only.
This shows you how to do it with a light and light things in different ways until
The
finally
only
he
force
feels
resisting the motion is that of
about, let's see, somewhere around like 1404-ish, 1405.
against.
There go
I switch the
AFK.
motor on, and then the levitation. See that again? The motor is still running. There's still some smoke coming from the motor, but that's not intended. It's just
Yeah.
because it's a very small machine. And talking of scaling up, Unfortunately, the levitation system doesn't readily scale up because a full-size one would be too expensive in terms of power input and in terms of track cost. But the air cushion principle, which was invented by Sir Christopher Cockerell for hovercraft, can be married to the linear motor to produce what is called a tracked hovercraft.
And this is 50 some odd years ago. And we thought we were going to go to the moon and we still have cars.
This is no model.
This is
the real thing.
We could be way ahead of
An air
ourselves if
cushion
we had
vehicle
thought about it.
running on a concrete track in
Yes.
Cambridgeshire.
charged, not
This
magnetic.
vehicle is driven by a linear motor,
Yes.
which is designed for speeds up to 150 miles an hour.
He's using both, obviously. You can't have one without
Nearly
the
2
other.
miles of track,
Well, the one
so flat and straight that the eye can detect no flaws, is an impressive sight in itself.
it's a different system than
And this is
magnetic.
the motor that drives it in course of construction.
Well, yes, but he's trying. This
Coils
is
are
just to
being
give you an
dropped
idea
into
about the
slots in a laminated
ways that
steel
the
core.
engine works,
And
like
the
the
whole
motor.
motor is about 12 feet long.
Getting an idea of what it looks like. I wanted to show you this so that you can go, oh,
I'm going to show you just one or two of the problems that are associated with trying to make a high-speed
yes, I
linear
could already
motor.
imagine them just by looking at
This
it.
block represents the iron part of the motor, or its magnetic circuit. And it's into the slots of this that we're going to put the electric windings. We might decide to put one in there and one in there, so as to make this a
I'm
north
back.
pole and this a
Welcome
south.
back.
The question is, what fixes the speed?
Just let me know when you
travel
want
of
me
the
to shut
field?
it off.
Well, if you're feeding the coils from 50 cycles per second supply, then the field will travel from there to there in a 50th of a second. And so you can work out the speed. And you see that the speed fixes the length of the coils. But we're not going to leave all these slots empty in between because that would be a waste of good space. So we're going to fill them up like this with coils carrying different phases of current as indicated by the colors. Try and fill up each slot. And now it's becoming increasingly difficult to get this end into the slot. This end will go in all right, but this one, you see, is getting very tight indeed because we're building up a bunch of end windings there. Now, this is a great drawback because this part of the current is the useful bit, producing the thrust. This part is just waste. Not only is it waste, but it produces a magnetic field of its own, which does nothing except waste your applied voltage. Now, what length of coil would you need to have to produce a traveling magnetic field at 250 miles an hour? The answer turns out to be 4'6". So can you just imagine how these problems would be magnified when you have to deal with coils 4'6" long? You'd be putting one end in a slot over there and the other one 4'6" away over there. And then the next coil. And so on. And this end winding would have built up to something quite impossible by the time you'd filled all these slots. And that's as far as the electric circuit's concerned. Magnetically, all the magnetic flux through these teeth has got to find its way back up the core. And so the core has to be very deep. And so it seemed for a long time as though it was going to be absolutely impossible to design a 250-mile-an-hour motor to be fed directly from the mains, and yet not to use the mains was going to be very expensive. And then we started to think about shape first and the motor afterwards. And we realized that all the motors we'd been making could be represented by a shape model, if you like, of that kind, showing that the magnetic circuits in red are in vertical planes, the electric circuits, or the coils, in horizontal planes, as shown by the black lines, and then said, suppose we were to change that radically. Suppose we were to turn the plane of the electric circuits through 90 degrees and make a model like that, in which the electric circuits were now in this vertical plane. Now let's see what that's done for the system. In particular, let's see what it means in relation to these small coils. Originally, these coils were in horizontal planes. Now I'm going to replace them in vertical planes, like this. And at once you see that I can have as many coils in one pole pitch as I like without the ends interfering with each other in any way. So this was obviously a good change to make. Well, we made a motor like this and found that we made it worse. When we examined why, we found that the end windings now of the coils were producing more magnetic leakage than before. And the main magnetic field still had to thread its weary way along a very large chunk of steel. So the system was uneconomical. But at least we got this far. We knew how to make it worse. And so it ought to be fairly obvious how to make it better. And we said if turning the electric circuit through a right angle into this plane has made it worse, then we chose the wrong circuit. We should have turned the magnetic circuit into this plane and left the electric circuit horizontal as it was before. Now, turning the magnetic circuit through a right angle means that we should have had another row of magnets along here and sent all the magnetic field from one side across, sideways into the other. Now, without going too deeply into the glories of these transverse flux machines, as we call them, I'll just show you one such machine and some of the things that it can do. The magnetic arrangement is very simple. It's just a row of horseshoe magnets arranged sideways and single coils magnetizing them. The phase of the current in this coil is ahead of the phase in this one and so on, so you get a phase progression and a traveling field. Watch what happens when I switch it on. It lifts, it propels, it's stable sideways, twist. See how rapidly it recovers when you disturb it. And you haven't really seen electromagnetic levitation until I turn up the current to its full value.
I've never been one
And then see what...
to-
You shutting it off?
I wanted to see that.
Oh, that's your actually, yeah, he's...
I was trying to unmute. I'm unmuted now. Yeah, I don't want to show too much of it because I don't want to get in trouble. What?
Well,
If
you can leave a link in the description, just
Right.
because I mean it's only 23 minutes long or something like that.
Okay, I wanted to
And-
ask a question about this part.
Sure.
Now, this metal piece is floating on an electric field that this bottom thing is creating.
Correct.
So if you were to take the bottom thing and put it on this and turn it around, then it could control itself.
Well,
Right?
yes, as long as it was going along that piece of metal.
Uh-huh. Yeah, but you got to be able to get it to go.
But why would you
Anything.
want to make it heavier when you could actually make the power source external to the vehicle? That way you won't have to carry it around.
And you can put
Okay.
more people on it.
Yeah.
Yeah, well, the electrogravitics that was explained to me with very
Oh, this is not electrogravitics. This is
Okay.
electromagnetic levitation.
this
which
led to
is-
gravity.
This is going to be, this should be, if nothing else, the first learning lesson of anyone who's going to start playing in electrogravitics, because
Right.
this is not the same thing.
Prerequisite.
The prerequisite, exactly. Now,
It's akin
what
to
is,
a gravitic.
yes, but you're going to see that they're using electromagnetics to create something that this thing cannot get close enough to. But the way that he's doing it right now is he's showing not only can I stabilize it, but I can stabilize it in every possible direction. And it will still run perfectly. If you just hit play, you'll see that he's going to basically, it can't fly off the track.
It's got 2 minutes left. Let's watch.
If you could figure out a way to bleed off negative charge from an object and making that object more positively charged, if Wall's right,
That's called ionization, yeah.
it will levitate off of you.
So
Yes,
now
if you can repel that, yes.
This is a truly amazing machine. It's as if there were some kind of a magnetic groove along which this will travel. It's stable in all three axes, both rotationally and translationally, and it will propel itself as well.
Stable
Just see it
because
again.
it's being held within the magnetic field line.
looks like doing mini train.
is a scale model of a high-speed transport system using a transverse flux motor.
You can shut it off
Inside
now.
the track,
Yep.
there is a row of horseshoe magnets
just gonna show
arranged
the same
sideways,
thing, but-
each with its own magnetizing
off?
coil.
Toy version.
But in
Yeah,
this case,
yeah.
the vehicle...
All right, and then I'll show you the other one.
The only cool disadvantage of this is that basically, as it moves forward, it activates the next cycle. So basically, it's only running power to the parts that are where the train is. See?
Okay.
Right.
It's a brilliant idea. Brilliant.
And those parts are in different phases. Each of those parts.
Oh, that I was
Permanent
showing
magnets
you.
are difficult things to understand.
You don't have to watch this one. I was giving you examples of he's going to show like levitating spheres and stuff like that closer to the end. So I thought you might be interested in that.
All right, well, like I said, if YouTube doesn't mind, I don't mind. But I just, I've been hammered so many times for the littlest shit.
Oh,
They
yeah,
got-
I know.
They
Let's
got
just
me
continue
yesterday.
The conversation.
Yeah. Yeah. Well, we can just watch the last few minutes of this.
Well, I just want you to see if there's a ball that floats in the air, you should be able to see it. It's pretty big.
The ball that floats in the air.
No, I think it's much closer to the end. Or maybe it's not. Maybe I got the wrong one.
Use a traveling field as well as give lift and guidance. The thing we're...
Wow.
There you go, buddy. That's how you
That's
design it.
Now, I'm going to change over
Anyway,
two
obviously I got
of the
the wrong one.
connections
But
to this
clearly-
end of the track
Clearly, there are some things in here that
so as to make it
There's
fire
your rail gun.
backwards.
Yeah.
Yeah, that's
That's what-
basically-
that's what
no,
made me think
Not
of.
not quite, because a railgun is just using amperes.
Now let's see what happens
He's
to our
using
aluminium plate.
electromagnetism, not just.
Put John.
That's just on the bottom. The
That's enough.
coil.
Look
Sends it through the inner part of the
at that, it's going back and forth.
Right. You know what reminds me of railgun?
Well,
You know
obviously it
that
does.
that video that leaked out from one of the it was one of the probes. I mean, one of the Voyager. One of the shuttles, and they
You
caught.
just named several different things.
All right, it was a shuttle. I
Okay.
think it was Atlantis, and it showed this like little droplet of light go up towards the Earth, and you saw two flashes. Then you see it leave real quick, and you see two things like shotgun pellets go phew phew. That thing that shot them pellets, whatever they were, made it from the ground to space in less than a second.
Yeah, they had no mass.
You know what I'm talking about? You know which
Oh, yes,
one
I
I'm
do,
talking about?
yes.
Yes. That was pretty crazy. And the thing looked, like,
imagine
took
if
off.
you were, imagine if you were on the ground, you were ball lightning, then suddenly you start spooling up, following Wall's theory about, or actually Don Scott's theory regarding the nuclear reactions inside of ball lightning. Then this
Someone
thing,
was shooting at that
someone
crap.
changes polarity. Okay,
Yeah,
no, like let's see this ball lightning changes
the
polarity.
railgun.
And suddenly it's negatively charged. Well, if it's negatively charged, it's completely opposite to the ground charge. So the ground is negatively charged, so it's going to go flying away from it. It doesn't weigh anything. It doesn't have any mass, and it's not affected by air. So it's just going to go. This electromagnetic form or plasmoid has no mass. It can fly right up to the ionosphere in instant. And then why would it split? Because basically it's going along to different areas where they will find equal charge or charge stronger than it, and it breaks up. That's no problem.
Like-
That's
Comet Shoemaker Levy? Nah.
or the 2013 comet when it came in over Russia, it exploded like a shotgun.
Oh,
I
yeah.
put a whole,
Oh yeah.
although obviously Don Scott talked about electric fissioning in his book, the idea of fissioning, because basically, let's say you're the sun, and then someone gives you more charge per cubic or per square meter, and then you go, okay, I need more. I can't. I'm high, but I can take more. You get more. I can still hold together. You take more. Now you're at your maximum limit. You're blue-white. You can't take any more. What happens if you get more? If you get more, your core touches your surface, and you're going to blow out another planet, or probably several planets. Because your core is positive, and it's going to go all rushing to this point and explode out some planets from the inside of this body. That is probably how planets get made. But this fissioning, when it happens, say, to an asteroid or bolide coming into the Earth's atmosphere or something like that, happens at a pretty high altitude beyond, like, it was quite high, and it just exploded like a shotgun because it's like, I need to increase my surface area because of all the electrons hitting me. And
yeah, like
it did.
like the probe in the Sapphire project when it
Detonated?
when they breached the double layer and poof, it disintegrated.
You can find a video, 2013, of Russian asteroid, Russian meteor. No.
Yeah.
Meteor. I'll go with meteor.
Yeah.
There. Looks like the top link. You know, I mean, well, at least there we know it happened. Here. See, and then it was like, shoosh. It was blown to pieces. Just turned into a bunch of smaller objects. Basically because the Earth does have a defense mechanism for these objects.
Yeah, that's its surface being negatively charged.
Well, we have an atmosphere. The atmosphere alone can bring material from the atmosphere to it. That's basically what's happening right here. Like so many electrons were heading straight towards that thing. Like going, no. You know, just to stick to the side of it because it was so, you know, impressive.
Differently charged.
Differently charged. And it's attracting them as it gets deeper into the atmosphere. And then it's like, I can't handle this. Okay, well, just make yourself into a bigger object. How do I do that? Explode into multiple objects. Not physically bigger, but covering more surface area, I guess is what I mean.
Yeah. Hence the explosion.
Yes. You can see them building up just before it happened. It's not an external flame that was hitting them, the friction of the air or some weird stuff like that.
So partly it would be friction of the air. But a lot of it is electrons rushing to that object and attaching themselves to it, and woof.
You want me to stop sharing?
No, I just don't know what's where we're going from here. What we're talking about, and I haven't heard of where Andrew is either. Is he?
I was babbling away, and the damn mic was off. What do you guys, what do you guys think of Terrence Howard and his stuff? Has he been watching some Thunderbolts videos or what?
Well, actually, you can blame me.
I can blame you?
Yeah, that's my fault.
How is that your fault, man?
Well, as oh, no, it's sure there. As you know, Shockwave and I did it like a 3.5-hour interview with him.
You did?
I don't know if Shockwave was actually there now that I think about it, but either way, I did the Electric View has like a 3-hour interview on him, which if you watch them back to back, that interview and his discussion with Joe Rogan, you could hear my voice going through his lips in a few places. Like, no, the electricity was more powerful back then in the past. And I was like, wow, you know, that type of thing. I'm not. And don't worry, I'm not.
He had left the show by the time I came in.
Okay.
So let me get this straight. Terrence Howard used to be on the Electric View.
Yes.
Yeah.
You can just type in Terrence Howard, the Electric View. We did 2 things with him.
He was
Oh,
pretty big
wait,
in the
it will
electric
be
universe. He was into it big time.
He's not into, I wouldn't say into the electric universe, but I definitely dropped some stuff on him that made it into that interview for sure. Like when he started talking about the ancient pyramids being like, they were closer to the ground.
I've been having
Like the ionosphere was closer to the ground, and I was like, and then he said the same thing on Joe Rogan, and I was like, oh, that's nice. And
Yeah,
I'm not mad. Not mad.
it's-
I'm only here to educate or to try to propose, so I shouldn't be upset.
It's
I'm
a higher
actually-
potential.
Well,
The
obviously.
potential was higher, right? Because
Well, it was the more
there was
volts
more
per
charge.
meter. Yeah.
more charge in the air.
Can't
and-
find it? Do you want me to locate it for you?
Oh, fine. Yeah, put it in chat if you could. Let's see.
And the ground had its charge because the Earth was being fed energy by the sun now instead of just Saturn.
So you guys had him and his views before. Was he an actor then? Was he already?
Yeah, no, I was
Yeah,
not that old. He still played Iron Man in 2008, so Electric View was only like, it
So
was
you
10
guys
years later.
caught on to a real.
There you go. You got the first one.
And the second.
I don't know if the second one is actually from us.
I'm going to have to watch it.
Oh, sorry,
I'm gonna-
third one.
But yeah, no, the top one was us when he was talking about helping the Russell.
Keep
let's-
the view
Russell-
alive. Keep
Let's
the
watch
view
a few.
alive.
Let's watch a few minutes of it. Well,
Hey, Lily, how you doing?
Peachy Keen, Jelly Bean.
So
How about yourself?
Just go anywhere to the middle if you want.
Okay.
Just pick a spot. I have no idea how long this is.
I like it.
I would have called you earlier, Lily, but I just got back. I
Oh
thought
no, you have perfect timing. I just
Mute
took
yourself,
Mr.
Craig.
Pickles out and just got back in.
Say about the middle.
Yeah.
near where Lily lives in Oregon there that there have been, they sort of melt and move as they cross the surface, but they're mostly stable.
Yeah, I will.
This is, of course,
on the video.
you know, no one wants to really admit this. You have to, you know, you have to see this for yourself, because it's, you know, it's, no one's going to admit, no astronomer is going to admit. But you're not wrong, by the way, when you were talking about the nature of the ionosphere of the Earth, where electrical forces will impinge upon the ionosphere, and that would be the upper tuft of the sun, just below some of this action here, and this, and it would be the corona. Then would be like our thermosphere. So the circuit is very similar, and
I think I was
that it's
talking about the
similar
circuit of
probably
the Earth, I'm
because
guessing.
of, like we talked about before, the homopolar motor effect. It just works on the same basic principles of a
That's,
homopolar motor, but in sphere form, which creates its own secondary currents and tons of other interesting phenomenon. So
It's a bad sign.
Yes, well, there's
You're gonna
a
say it in a
few
second.
ideas, unfortunately, in the even in the EU, that are still wrong about the current flow, and that you get that bigger picture when you see how the sun fits into like the interstellar streams and what stars are also
That's
in that.
Jim Winninger,
But
people.
the whole idea is
Ah,
the
That's
sun
you.
is not an endpoint for current. It's
it's a load. That's all it is. It's a inductive and resistive load on the circuit. That's
So, middle of,
yeah, you have to have current flowing
Through
through
it,
and that,
yeah.
all the evidence.
A Z pinch.
Otherwise, the sun would run down over time, or the current flow would have to change over time as it becomes more positively or negatively charged. But we do see a lag in the solar cycle in the southern hemisphere compared to the north. And what I'll argue is that that's exactly what, if the sun has any capacitance at all, that's a simple way to put it. We should be getting current, but it's not continuous current.
anyway, I don't know where he is on his voice is, by the way.
Discharges, and
you
that's
can't hear it?
what we're seeing over
No, I can
time.
hear
That's
it.
Why the lag
I'm not hearing him.
from the
Yeah. Oh, it's okay. I'm just checking out a little bit of it. What's all this?
I don't know.
astronomical
Someone else was
measurements
screaming at the
we're
time.
headed towards
Oh,
the north
okay.
ecliptic pole. That's even illustrated by, like Michael Claridge had that picture, and I think
Right.
Don Scott too, and that other guy on the internet that showed
Look at
the
a little.
solar system moving like a vortex. I don't know how they figured
in the description.
it is.
I've seen that too. Yeah.
Let's show some more to my
Okay,
life.
let's
and
see.
He's got the.
That was Jim. Jim did that.
Yeah. There's a few people that are really surprisingly into some details. There's a couple.
Who's talking right now?
Jim Winninger.
Jim Winninger.
10.
I don't know.
Working on just the circuitry alone of
He's a smart man.
Yes.
Clouds, how the charge is flowing and.
Good.
Anyway, grab.
But yeah,
Just try to jump somewhere else earlier, later. I don't know. Like quite potent in that respect. But the
and it's also visible, and
that's him. Oh, sure, and there's
the whole spectrum.
Well, the explosion
Terrence
basically
Howard?
going along that whole strip. Yeah, because it's exploding the air outwards and so forth.
That wasn't.
But
Terrence Howard.
But there are certain places.
Well, go to the beginning then.
I don't want to
introduce him at
completely
least.
wrong here, so please help me, Jim, if you can.
They know that gravity.
Like just move it to like 10, 15 minutes.
I want to get back to what we were just talking about.
Somewhere.
And Ito and Jim were talking about this balance point, which I'm super interested in, by the way.
The balance point. Okay. Go on.
So
just keep moving forward
Jim,
so we can hear his
here to
voice.
Pick up where we.
The electrostatic forces.
Keep going. Terrence Howard has a distinct voice. So.
We can calculate what it is on the surface.
May I ask a question?
Keep going.
1,000 trillion.
Keep going. No, they have the same exact R squared radius. Till he's talk there. That
at that radius. See, we're told that we're taught 10 to the 37.
Get higher electromagnetic energy in certain spots.
About how that falls in relation to this.
Well, I think that's if I'm spinning at 36,000 times a second, and no material can hold. I don't know where it's at. Okay, he's in here somewhere.
But
it's okay. I believe you.
This is and the thickness of the
obviously I
double
labeled
the thickness
it.
of the sun's atmosphere,
Sure he
so to
is,
speak.
Neil.
I can envision.
Yeah, right.
Sure, you
Thinking
got
the whole
it.
planet expands. I recognize that there could be a.
I'm just.
Or ideas with this,
Is that him?
which you were discussing. Start.
Yeah, he sure don't talk very much.
So
There he is.
talking about hollow planets and stuff. Is that related to Rawls' theory of gravity?
Actually, we were talking about gravity. Jim had pointed out that there is a layer,
second ago.
Or there's a balance point, and that modern astronomers had forgotten and dismissed electricity and the voltage or the Coulomb charge of the sun
Keep going
after
forward.
1920.
Yeah, keep going. He has to be here, man.
Aren't as positive ions moving toward the sun? So
Keep going.
there's no mystery from the EU.
I could envision.
from the side, the mistake is thinking something on a smaller scale.
Where is he?
You're going to be thrown way off because
That's okay, man.
No,
he's here.
Right
He
above
has
it.
to be
This
here.
gives us our. That is
It was
coming out from
early
that-
in your
that
show,
orange
was it?
Strip
I
along
mean,
the
this
middle of
is
the sun
2,
that
3,
you see.
4 years ago.
It's
so-
usually,
He's probably
so
near
if they
the
sit
end.
in the
He's
middle,
probably just sitting
they
there
are
listening.
neutral and
There's
they'll
Buddy.
hover there without issue.
Buddy?
Well, they experience if they're off the ellipse.
I can just see that. I just saw his face.
That,
Is that Terry?
and they experience a force pushing them
No,
back.
that's not Terry. Well, I don't know
And
that
that's
guy's
yes.
name.
Except what I don't understand about. Oh, never mind. Go ahead.
I have a weird question. If the
Yes, sir.
the field
No.
the field rapidly can some of the rings form?
Oh, well, I believe you.
You mean when
I'm
the
just
moon was
wondering what
when the moon was built. No, I think
No.
I think according to a lot of Saturnians, when we move,
I'll
Saturnians
keep
like-
these rings, these shows, and show them.
Well, just go to like he's in there somewhere at the end. I'm sure. I don't know when he showed up. But
okay,
you can go to the other one. He's right there at the beginning.
okay. Let me just save this link so I don't have. This is saving myself.
Yes.
Okay, this is where I keep my junk and my notes and all that shit. All right, so the first thing you say was that. Okay, Because
Yeah, you found two of them.
I just kind of fell into a bucket of worms. I really just asked you what your thoughts were on his. Some of his theories seem kind of out there, you know.
Well, yes, but
this
that wasn't my. But the stuff we were talking about, as you could tell,
Yeah.
in front of him, definitely sunk in. But
Yes.
you
That's
can
what I thought.
drop that in. Anyway, which one was his?
Drop it in chat. But
Well, you know what? You just had it a moment ago. It was Terrence Howard.
all you would have had to
back
do is
up.
click
Well,
back up on that video.
Part of this deals with another part of it that I haven't talked about. How I even found out about Terrence Howard was that I saw this show. Hi. I saw this show from some idiot. That's really all I can think of when I think of him. His name is Professor Dave. Well, this guy, he had a video that said Terrence Howard is an idiot. So I watched it, and in that video, he said it looks like he watched a couple of Thunderbolts hokey videos on the electric. You know, like that dude. I can't get through 5 minutes of that guy. I wanted to just squeeze him in the throat. You know what I mean?
Well, I'll show you two things I have there. Here, you can
Dude's a phony.
And
I don't even know him. I don't want to insult him. I'm just, to me, you know, he just doesn't know what he's talking about.
Oh no, he some of the things that he talked about, I can probably agree with.
Oh yeah, on Terrence Howard, but not on the Electric Universe.
Oh well, no, but he hates the Electric Universe.
Yeah, he does. But I mean, doesn't common sense, uncommon sense seep in?
Not really. Okay, there's a chat. Okay.
He did. He did an Electric Universe, a Thunderbolts show when we were doing the Electric View, Greg.
Okay.
Actually, I have a copy of that too.
I'm just finding this out. I did not know. Let's check this out. And Walter Russell. Yeah, Walter Russell. Now I know him.
Yeah. That was the other guy talking besides Jim.
There was another guy in the early 1900s named George Woodward. That was great too.
And that's our reply to the. You skip ahead. You don't need to watch the intro here.
No, I think it's pretty cool.
There's a guy.
I like intro.
It's advertising.
University of Science and Philosophy is opening up for the first time in the universe the Walter Russell Museum, and it is gigantic. It's way bigger than I thought it was going to be. And
well, you're the big guy right now, but I'll take Buddy too.
No, we're doing all right.
See?
I mean,
There they are.
everybody, I just hit 50.
The other guy.
About 20
That's
minutes
Terrence
from
Howard.
finishing my. Well, no,
Who was
got
Oh, that was Buddy.
Buddy
my
who?
book one time.
The guy who introduced me to Terrence Howard.
Two.
Buddy Dougherty.
I'm just
Buddy-
about 2
Buddy
minutes
James?
from finishing that. I just got DJ to finish
I've
up some
heard
pictures
him.
for me.
Anyway,
some
this
last
is
shots that I
that
need
show.
for
You
it.
know,
I was supposed to speak at his event, and I couldn't because I had laryngitis. That was the beginning
Why?
of all the cancer shit.
Why don't you have him on your show? Neil or I could set you up with him.
Well, yeah, that's
He's
not
in
a problem.
Skype.
I already told him that a long time ago, but I kind of got the sense that he really didn't care much for me, and so I didn't. I just let it go.
He's a good guy, and
I wouldn't really worry about it. I mean, there's very few shows that actually have people chatting nowadays.
Yeah.
And hi, Cindy. I'm sorry if we didn't get a
Hey,
chance to
what's
say
up,
more.
Polly? We were in the middle of this shit.
Yeah, we were
I'm
doing
I'm eating dinner anyway, so I'm listening.
All
Okay,
right.
that's cool.
I said hi already. I'm sure she heard me.
There.
I
So now I can prove that he was on the show.
Yeah, for sure. That's
but
awesome.
The other one, the Electric Universe Debunked, the one I linked there for you, that's the one where we talked about Professor Dave.
Yeah.
That dude's man.
Oh, I nailed him very much with
It's
quotes from.
I haven't watched it yet because I don't know if I can.
Don't worry
It's in
about
the-
that. Watch what I wrote about him, so that you can see that my citations are direct from people who are in the sciences and have had to deal with, you know, Professor Dave comes from a place where he believes that academic science is always going to give you the truth. And in places, no, this is not a wrong thing in some areas. For example, if you build it wrong in engineering, it doesn't work and you get fired. If you do it wrong, make a wrong calculation in astronomy, they won't figure it out for 50 fucking years.
Greg, this is a video that we did
debunking
his debunking of the electric universe.
You would like it.
Yeah, you'd enjoy it. Yeah.
So let's hit play.
No, not this one.
See this.
No, not this one.
No, this is the Walter Russell one.
Oh.
The other one I just linked to you.
It's in the chat in Skype again.
Yep, like it was supposed to be.
Yeah. All right.
Hey.
Right here.
That guy. That handsome dude. Click on him. Yeah.
And you can jump ahead to
that's great work on the intro, Neil.
Oh, thank you. Yes,
excellent.
It was.
I appreciate things.
He's had a few different intros.
I'm not changing this one. This one.
I like.
Yeah, this one's beauty. You could turn it down.
Recently, I watched a video debunking the electric universe, and I felt it necessary to
even
respond.
more a little bit.
I understand the motivations of the gentleman. He was trying to protect people from pseudoscience, like the flat Earth, but he kind of was throwing the baby out with the bathwater, or perhaps not realizing how well founded the electric universe model is, including with the IEEE. So his points.
Don't worry about it. Don't worry about me talking if you want.
Future, but
just go to like
at the
10
end,
minutes or something.
Something that I thought was.
Who is this person?
That's me.
This is Neil.
Oh.
That's why I said click on this.
Anyway, see, I'm talking about his romantic notion about science.
Brotherhood of man, that there is only science and there is not other science. Obviously, clearly, this is not true. Science is the same until it's changed, or there is rival competing sets of sciences like you have with the Soviet Union and the United States. Now, countries in the middle, such as Sweden, Finland, and others who could basically walk the line, perhaps, are some of the people that were the founders of the electric universe model. The idea that the electric universe was not even thought about or is a new thing, it's clearly not. It's been, I mean,
at least 100.
It's as old as Einstein is.
Yeah, there's a lot.
You know, we're talking Kristen Birkeland, 1895, going up and measuring the current underneath the Aurora Borealis. His fights with Sidney Chapman, all of this. This Hannes Alfvén, who became literally the father of plasma cosmology and won the Nobel Prize in 1970 for that work. To think that, and he warned people then that you don't use my original work, because I said that space is superconductive, and it's not. Plasma is in no cases superconductive. There is a resistance. Therefore, there's an electric field. Therefore, that is what is generating the magnetic field. This is not magnetohydrodynamics. You'll miss certain things like double layers.
See, I basically, this is from NASA,
more or less the warning that he gave, and
you can find this on NASA.
It's not something that should be taken lightly.
Yeah, but that's good.
It doesn't mean that you have to throw out all the models, that conventional astronomers are incorrect on everything, or that astrophysics is incorrect on everything.
You can just jump ahead.
In an electrical case, to call something a wind of charged particles, or to call something a bow shock in relationship to that is disingenuous. These are electrical phenomena, patently so. This is not something that we can even debate, really. I mean, these are charged bodies immersed in a plasma. This plasma
theory is not very much different than Ptolemy's,
as it should, trying to ground itself out along the solar wind.
And creating multiple double layers and
not unusual. Plasmoids exist inside the tail of the Earth, even. We know that is there. It's nothing illusory or something. We know the principles on how this is founded. We understand how charge is conveyed. We understand that Earth has charged particles. These charged particles are interacting with the charged solar wind, and as such,
I think we all know
brought
this.
along by it.
But
as you read in the paper by Hans Alfing, no professor, no electrical engineering textbook will tell you that magnetic reconnection can exist. It's a fallacy.
Yeah.
It is a pseudoscientific
Don
concept.
Scott.
The only reason for such a thing to exist is to basically eliminate the need for the electric field to even be present in astrophysical plasma.
729
easier, but it
probably be good.
It's not correct.
Just
the
because
actual
I mean,
mechanism.
don't get me wrong. I love hearing
by
my own
which
voice.
the electric
But
fields are generated. Why shouldn't we challenge these things?
Here, why shouldn't we challenge?
Let's get right to it. Let's hear some people talk about the problem within the sciences.
So the theoreticians ought to be really looking at this theoretical problem.
Very well done.
And the observers ought to.
Well, I wanted to use these as the evidence because these are all.
But I think they're all a little
You
scared.
need to get back to making videos again.
Subject.
Thank you.
They're worried about their jobs and they're worried about getting moving on up the ladder. You know, if they're postdocs.
A young person in academia cannot afford to go against the Big Bang. He'd immediately lose his position. Tenure. Yeah.
When I was a student, I was.
This guy's a pussy.
When I saw the
This
chance
guy, I like
to
him.
work with Chibar.
Oh, I like him, but he's a pussy for sitting on the fence. He knows winners.
Yes, but you can't do that.
And warning me now that you may find some people.
You know you can't do that. These guys have much more to lose. I don't.
I didn't even understand.
Yeah, I suppose you do.
I'm just trying. You know, we're just.
I'm an engineer. He's in the science.
Just investigating other areas, alternatives.
As long as I ran the plant well or did my job well, it wouldn't matter.
And that there was a deal of hostility. Now we're entering the realm of
Has to be within the paradigm to get
religion, philosophy, metaphysics, and
That's what he's
science.
talking about. All meet.
And make no mistake about it, they all play a role in our beliefs. The amount of data that we actually have to support any particular model is small. It's mostly consistency.
Just so everybody knows, this is a video about Halton
radiation. Yes,
this particular video.
Yes,
I grabbed it
Big
from
Bang
that.
context, but I believe Fred Hoyle and Jan Harlecar and Jeff Burbidge have suggested an alternate explanation. And I'm sure we could find 10 more.
Energy and blackout.
But strangely enough, it's not.
Mosh.
You don't get tenure in the university, you don't get promoted, you don't get recognition. By looking
The words got to make sense.
This guy is smart.
It's not a science.
See?
It has a lot of scientific aspects. We can know many things with the science. We can know how the galaxies are distributed, and this is our measured with the observations. We can know how rich are the metal, how many metals are in the intergalactic medium or in some galaxy, and all these aspects are scientific. But with regard to some considerations about the beginning of the universe, this is in some way crossing the barrier of the science and going to something in between the science and metaphysical speculation.
Speculative.
Sociology is very important.
Now, this guy made me realize something.
Are in groups and gangs.
That science, the actual institutions are older than the science of psychology.
You want to be one of the boys, one of the dare I say, one of the girls. It's the same after all. And
it's the same after all.
You tend to think alike.
He was actually very forward thinking for 1990, whatever.
Well, yeah, I mean, come on,
I asked them, how do you resolve the disagreements amongst yourselves? And the reply was, we vote.
Just as good.
What a strange thing to do in science. Vote. I would think the best thing is that all 7 of you disagree. But there's a feeling that creates chaos. And the argument that we need some common thread or road to follow.
We do.
For the majority to follow
Okay.
in order to have some kind of
About this?
organization to the whole
The only
scientific
thing the
universe.
mainstream can think
No.
of.
It's an
His
argument for that. But
Dave's
when it
argument
becomes
that there was
all
never any problems with
so that no
science,
other
and I was basically
possibilities can even
showing,
be
here's a bunch of
explored,
people
that
saying
is not good.
science itself, the structure of it.
In
This
the
is
case of
Right.
1971.
there
This
is
is good.
Yeah, I've seen this guy too.
and
He's
the
just
cost
brilliant.
of being
I like
himself
him.
has been very, very great. That is a condition to which I think the young profitably can be exposed. And if I had my way, every young undergraduate student in my college, everyone, whether he's in the humanities or the hard sciences, would be required to examine the Velikovsky case. First, because the subject matter of what the man is standing for is very interesting. Very, very interesting. Secondly, because the subject matter is truly interdisciplinary. It's stretching. But third, because the human embodiment of the expression of the ideas, in a way, is symbolic of the problem the young think they are facing in this kind of a society, and which, in my opinion, they
And this
in
was
fact
50
are
years
facing.
ago.
Not only them, me.
Not just them, me.
But what is this?
What is this condition?
The problem, the
We're
condition
so
is
upside
the
down.
extreme professionalization and rigidification of institutions through which
People
thought
don't
is
even
supposed
know.
to occur. Extreme to the point where it begins to contaminate the fluidity and looseness, the freedom to think.
And Dave didn't understand
Fluidity and looseness of ideas, of having ideas, and the freedom.
because he was
to
born
think.
in.
Right.
Velikovsky really wasn't taken on by the establishment simply because of what he was saying. He was also taken on by the establishment, in my opinion, because of his audacity in having such thoughts.
Yeah.
That is what Dave tried to do to us. He basically said, you dare think outside of the realm of Einstein? You must be punished. Get out the fires. Where is the books on this?
Yeah.
You know, like, what the heck?
I must create
We're
a
literally just saying no.
Well,
Like basically I was saying, here's perfect examples of people throughout the last few years saying, yeah, if you go against the establishment, they hurt you. I mean, they did it to Robert Schoch, and Robert Schoch only managed to even stay afloat because he hooked himself up with, I think, Hancock and a few others, and then managed to keep selling some books. Otherwise, he'd be homeless.
And
He's
these
not doing any
people that
work.
were talking in that video were a hell of a lot smarter than Professor Dave. So
Yeah.
that I take solace in that.
Well, I mean, not just the president of Staten Island College, but I mean, one of them was, I feel terrible not knowing her name, but the first lady there, Burbage, I think, she was the top astronomer for Reagan, for presidential astronomer.
Yeah.
Now, I don't know about you, but you don't get much higher than that.
Margaret.
And she said there's a problem.
Margaret something.
Yes, Margaret Burbage.
Something like that, yeah. Burbage.
That's like a brain.
Her
Well,
husband
obviously,
was,
yeah, you have a brain, that's for
was a
sure.
big deal.
Decisions on temporary feelings. That's a good one.
What's
Yeah,
that?
I'm not a big fan of this type of thing, actually.
What are you guys looking at?
I don't know. Whatever you're looking at.
Oh, okay. Or if you're typing, if you want to take over, just say so.
Oh, no. I'm
just giving
fine.
the people some eye candy.
I think that parts of the death cult ideas, especially when we were, I mean, there was a problem that death showed its face every night. That must have been horrifying.
Well, I mean, the reason, another thing that movie, the Cosmology Quest.
You're breaking up. I can't hear you. Houston?
Can you hear me?
Again now.
There's another thing.
No, it's gone again.
You must have turned away from the mic or something, Greg.
No, I don't know what it is. Can you hear me?
Yeah.
There's another reason that I learned. There's another thing I learned from Cosmology Quest, and that is the Big Bang never happened because redshift is non-cosmological. That's a huge thing.
Well, it is cosmological, but it's just a measure. If we're following Halton Arp's work, it's a measure of youth, not a measure of distance.
Right, the quasar, yeah, right.
But
As it
but
gains,
there is the Doppler redshift effect, and
Yeah.
that is proven because
Well,
they can
yes.
pick out stars on one side of a galaxy that are rotating towards us, and they'll be more redshifted than a bank of stars on the other side of the galaxy that are moving away from us. So there is
Basically,
some
there
truth
is.
to Doppler, but it's not as wide a field as they think it is.
Allow me to just place it a different way to make it a little
Go
bit
ahead.
clearer. Basically, there is redshift, which we understand, just like sound waves. However, clearly there is Doppler, yes. Clearly there is a, quote, non-cosmological factor to this redshift.
Yes,
And that's something that is not based on the speed or motion of objects, perhaps maybe based on their overall, well, I was going to say electric field intensity and charge, or, you know, because basically these are new and they have to build up mass.
Yeah.
You know.
Well, I see a correlation between new quasars being born and growing up, accumulating mass, maybe even in their plasmoid center, creating matter out of the ether. I don't know. That might be a stretch, but how do they gain in mass and keep gaining in mass?
That's actually pretty obvious. Once you
pulling in dust in the area?
No. Where do you think dust comes from? It's parts of planets. The material that they build, they make something, it explodes, and in that situation, or the electrification of the surface, they create a bunch of different materials, and gold and diamonds and rocks.
These plasmoids are created from the central jets of.
Well, yes, these quasars.
That's spitting out.
It's spitting out something, but you gotta understand that electrons will have to interact to create mass.
Right.
Like positive charges have to be made because they're, if for lack of a better term, we don't know what mass is. Number one, we don't even know what positive charges really are. But obviously there is a different. Yeah, no, I'm with you. But what I'm saying is, the surface of one of these things, like to just say it's there is one thing. To say we can see its shell was another thing in 1980. Now we can see it. You can't see the nucleus yet, but what would that look like? And what would be inside of it? Is it like fractal? Is it continuing going inside of itself, and that's what gives it mass?
I don't
you
know.
See what I mean? No, I mean that's just a layer of thoughts.
I know.
But the galaxies itself.
But what I'm getting at is when a plasmoid is created within the jet, that is called a quasar, and then
for lack of a better term, yes.
Now we've Halton has extrapolated.
I'm not arguing with
these are
any
getting
of this.
bigger and bigger and older and more blue as they attain more and more matter.
Correct.
And I
Basically,
think it might be that these plasmoids are highly charged with electrons, and then protons that enter the system join with these electrons, and that is the age thing for one, but that's the mechanism for the changing color of light.
I can't debate any particular thing on that. Basically, that is the idea that basically you go into BLAC objects, then up to quasars, and then you start stepping back in and become falling closer to your parent galaxy, which we are currently in the stage of doing. Our galaxy is approaching our parent, Andromeda.
Right.
Or
we'll end up
it looks blue shifted because we're not fully done becoming a galaxy yet, I know that that sounds stupid, but imagine we aren't, and we have everything wrong on this end. Could you imagine that we're actually in the process of actually
Getting bigger.
Getting bigger, and that's why it's blue shifted. You see what I mean? We couldn't tell the difference. Either it's coming towards us, or it's not, and it just looks that way because we are red shifted towards it.
And people, you got to remember, these galaxies and quasars that are being birthed from galaxies, when these quasars are birthed, they get shot into the flow of the free electrons and free matter that is flowing within the Birkeland current, and they're picking up that matter and accumulating it, and again, probably changing their redshift from red to blue over great spans of time.
You want to catch a few minutes of this?
Here, I think I might have a picture just to make it easier for your viewers.
No,
I want
viewers are watching what we're watching.
He wants them to watch this.
Oh no,
just for a few minutes.
Accident. So the real issue that you come down to is how frequently do you expect to see accidents?
If you look carefully at the pictures that were taken of this field, you will notice two faint stellar objects that are in that spiral arm.
Look at that.
This was before he created his book, Atlas of Peculiar Galaxies. This was the first one that he found.
No, or not true.
One of the first ones that he found.
Is the Atlas of Peculiar Galaxies. This is NGC 7603, I think. I know. That's how Greeky I am. Okay, I almost pretty sure what I think. But anyway, okay, and he never discovered the two quasars that are circled there. He only saw the tail connected to this galaxy, and they both have different redshifts.
Well,
that was in 1960. No, just let me finish.
He saw the far right one.
Let me finish. In 1968, and the future astronomers, especially the ones that were speaking Spanish, I'm not sure where they were from, with Spanish accents, I mean, probably Spain actually, helped find these two additional objects.
Yes.
If I'm not mistaken.
Well, on the original photo, you can clearly see that.
Yeah, but they weren't measured then.
They weren't measured. Okay.
Yeah, these are now given measurements.
He was speculating that.
Yeah, no, it was a good speculation because he was right.
Yeah.
No, I'm not arguing with you. Yeah.
No, I'm just saying this was the first one he found. He found many more later on, and that's what was being mentioned by the fellow in the red shirt. Go ahead.
There we go. I actually found a picture for you too.
Oh, are you okay? Ollie?
Huh? Yeah, I'm here. I'm listening.
I just was wondering. I heard you.
Yep, I'm here.
There's a good picture for you.
Well, one is close to NGC 7603, and the other one is close to the faint companion galaxy.
In the year 2001,
yes, you are.
When the two young Spanish astronomers worked on this.
They're Spanish.
Las Palmas telescope, they saw that there were these two condensations, stellar condensations. They looked like quasars, but everybody would have said that they had to have the same redshift as the central galaxy because they were obviously in this filament that had been ejected. What they found was that each of these objects had a much higher redshift, and that the filament itself had the same redshift and spectral composition as the galaxy from which it was ejected.
And they got some spectra using what's called the Nordic Optical Telescope in the Canary Islands on La Palma. It's not a very large telescope, but they got some excellent data. And they got spectra of these two faint objects, one by 7603 and one by the companion galaxy. And believe it or not, they showed that both of them were quasars.
Yeah, we'll just check out a little bit more. There's a really good part coming up.
Definite quasars.
You demand, Neil.
Sorry, I'm just taking a shot here.
Oh, you demand.
Now this one is quite good. redshift, and as it matured and evolved into our present form, that we were seeing the birth and evolution of galaxies in the universe.
That's what I said.
It only makes sense.
Yes.
This is amazing how they do this.
If proto-quasars ejected from the nucleus of active galaxies themselves evolve into new, younger galaxies, astrophysicists must find experimentally and observationally the mechanisms which describe this phenomena. One model explains that the proto-quasars...
Also, I would submit that these have to be young galaxies because the Milky Way isn't going to be spitting out any quasars anytime soon. It's only in these galaxies that are Seyfert.
are ejected.
There might be quasars that are related to, objects related to the Milky Way around it.
Could you imagine if a quasar come tearing out in the arm and right into our solar system, the havoc it would cause?
Extreme magnetic field aligned along the spiral arms.
What would
thus
happen if it
explaining the
didn't
torn,
get
disturbed
formed?
features
What would that look like?
often observed
Yeah.
in the galactic medium,
I'm serious.
and the frequent appearance
But the Milky
of
Way
high
seems
redshift
to be
companion
more
galaxies
established and
attached
older.
by filaments to
Yeah,
a
but
lower
we definitely
redshift
saw
parent
something
galaxy.
happen in the Pleiades within human memory.
Remember, now it shoots one out, but it'll also shoot one out at the bottom, too.
The other and
Yes.
most frequently observed alignment
What you should be
is when
not,
quasars
what you should be
appear to have
looking
been
at is a
directly
big
ejected out of the galaxy's
sort of,
active
magnetic
nucleus along its line
U
of least resistance,
coming out of
creating
this
a
thing.
field of systematically high to low redshift quasars, or younger to older evolved proto-galaxies. This
Like
is
it should
exemplified
look like
in
a
innumerable systems like the one
nucleus,
around the
or
galaxy
like
quasar
a
field of
a
NGC
nebula that's hourglass
3516.
shaped. But
If one
they're called
disregards
radio
the
lobes
proposed
of galaxies
redshift
because
distance
they're
to these
so
objects,
big.
observation
They're just
clearly
called
points to
radio lobes.
ejection as a likely explanation for their close vicinity to the central
Here's
galaxy.
the key right here.
What?
These galaxies, these are all going to eventually become galaxies. What else could they be? And they're connected in some, maybe not here, but in other ones, they're connected by a filament with different redshift speeds.
And this is
only mean one thing.
And this is my theory of the expansion of the universe. This is the only way the universe can expand is by
growing.
Galaxies shooting galaxies further away from them into an area where there is no galaxies.
What do you say about the big void?
On-
What the heck is that?
What big void?
Giant void. You know, where there's like light years upon light years with nothing in it.
Well, electricity doesn't fill voids. It makes them.
Is it the great detractor? Is that or attract?
No, the great attractor is not what they think it is. They say, number one, they say a gravitational force is number one, all they have is a gravitational force, okay?
Yep.
What's really going on is that the entire, if you think of a galaxy as a pitch, okay, you got to understand that the galaxy is aligned with a bunch of other galaxies, and that group of galaxies together is in itself in a pitch. And there's that whole tube of galaxies are all being powered through that tube coming to this group of galaxies. And then there's a supercluster of galaxies, which is even bigger, and that is in a pinch as well, with a bigger one than that one, where the other two pinches I talked about are one inside the other. So this is now this giant supercluster of galaxies is all traveling in one direction because of the electric force.
And
there's no great
you
attractor out there.
And you would have then created voids. Large voids of space where there's nothing.
We're
where
just on a
no
big
plasma.
Birkeland current, and we're all sort of aligned heading in that direction. And this is the same thing with like that. And the reason we're measuring the speed that way is because we look in that direction and we can see way freaking over there that something, although nothing is over there, that we're traveling towards that spot. But I think the line that we're on, the line is actually curved, and we're not actually going towards that spot. I think that we're going to go with the flow, as it were, And that object that because remember, we're only thinking in the terms of gravity. So if you think in the terms of gravity, there's no road that we're following, no river that this supercluster is going on. We're just heading towards that space over there.
Well,
but I don't think that's the case at all.
The map of the supercluster, to me, to my eye, kind of looks like the surface of the sun. What happens on these prominences?
Kind of looks like a spark to me.
Yeah, a spark, or like the prominence on the sun, where there's multiple lines, multiple radial lines coming off of a certain area, and it just looks like that to me. That's all.
Man, you can't get anything on Google anymore. It's all messed up. Oh well.
What are you looking for on Google?
Oh, was the great void in space that you can't miss it.
Is that are you even on Google?
Just type in void between galaxies.
Okay, void
search lock
between.
What is that?
What's search lock? That's not Google, is it?
No.
I don't know what the hell that is.
That's a new. I never heard of that search engine before.
Well, then maybe I should. Here, what's this? Where the hell? I can't show it.
Go to Google.
Okay. Google. Okay.
Oh, there's a fly in here.
Well, at least I don't have no flies to deal with.
My Google button is named evil.
Yeah.
What am I going to do? Okay.
Void between galaxies.
Void.
Or super void between galaxies.
Super void. Yeah, super void will do it.
Between her legs. I mean, galaxies.
Don't publish that, bad boy.
You want to go outside? Come on. Come in the container.
Yeah, she's
mad
at you, Greg, for saying that. She said she wants to take you outside.
He just flew into my container. I kid you not. I'm going to put him outside right now.
Don't take me out. It's not here either. I mean, what do you got to do?
Super void.
Okay.
I bet you I could find it.
I bet you can too.
You find it.
You the man, Neil and Greg.
Yeah, I'll look for it. Okay.
I can't find it.
Don't worry, I'll get it.
All right.
Show the picture that I just sent to you there. It's in the thing. Those are the Earth is in the center of that picture. Okay.
Okay.
And you can see that everything is stretched out.
In filamentary
You can zoom in on that if you want, but the Earth is in the very center of that picture.
How do you?
Okay. Well, I don't know how. Whatever your computer allows you to zoom in.
Yeah.
I don't know. Anyway, the point is, there you go. Okay, so in the middle is us. Okay, somewhere, doesn't matter. But you see these are all the galaxies and all the quasars, and you can see how they're all stretched out away from us, implying that we are the center of the universe.
Yes.
That alone should falsify any idea that we are.
Well, don't forget
that they're right. I mean, because we're clearly not.
Don't forget, this is all based on
redshifts.
Yes. So this could look slightly different than what it is, but it would look fairly similar because we see all of these clumps of matter, aka galaxies, in these areas. So to my eye, it looks electrical. It looks filamentary. I don't know about you guys.
Yeah, I think so.
Oh, well, I mean, yes, but you'd have to see that they're all stretched out because of that problem. And also, although I don't have the picture here, I did find a smaller version, but not one good enough for that. As was stated by Shockwave here, you end up seeing also, if you zoom it out, you start not real. This picture won't show it, but if you were zooming out, you would see rings, more or less, at certain distances. Basically, the galaxies, the quasars, form rings of distance around the Earth, which means that they are they're making steps down, like they would step down to the next voltage level and so on, which is
double layers again.
Double layers again?
Yeah, double layers. He's describing double layers.
Yeah.
Rings of separated rings that of that's what happened in the sapphire chamber, right?
Oh, now tell me what's going on with sapphire? I mean, I thought they were right on the verge of making some huge.
Sapphire is now known as Orion energy.
That could explain why I keep getting messages from them.
Oh, really?
A-U-R-O. Sorry, spell it, Neil, for me.
I don't know. I would say A-U-R-I-O-N.
No, it's not I. There's no I. Orion.
That would just.
E-U-R.
Anyway, is that the picture you're looking for?
What picture?
That one that I linked to you.
Yes, I saw it. I had it up.
No, the new one.
Oh, the new one.
You asked me to find.
Oh, that's it. Yes, that's it.
Super void.
Okay, I told you I could find it.
Yeah, that's pretty cool, man. Now I'm wondering. Some have said it could even be a highly advanced civilization cloaking themselves.
It is completely empty of both normal matter and dark matter,
which is not a thing. So that's easy to figure out.
Yeah.
Yeah.
I just thought that was funny that they added that in there.
Any kind.
Why wouldn't they just say? Why wouldn't they just say it's completely empty of matter, and then move on? I mean, come on, people. They got their
empty of both normal
heads
matter
shoved up their behind so far that they can't even hear them what they're saying to themselves.
You know, it's just like the Democratic Party. I mean, everything they say is a lie, like mainstream science.
I wouldn't really bring any politics into this because obviously, as someone who's outside and really kind of scared of Russians still because of I grew up I'm not really a big fan of having someone who hates NATO in charge. It's not a fan.
Well,
but
dude, I mean,
otherwise, everything else is your guys' job. Okay, it's your country. But just from my point of view, not giving Russia an inch would be better for me.
We'll stay out, yes, but China. Continuing the war.
No. I'm not even worried about that. I'm just saying remember, they're the ones who've had the war. If we had to send the bodies to die, it's not a good thing.
Well, Trump did say that he wants to build the Israeli
Stop.
The Iron Dome.
Stop.
That's all I'm going to say.
I don't care about any Iron Dome. I don't trust that guy as far as I can throw him.
Anyways, the void. Yeah, it's huge. It's massive, and that's not the only one. There's many of them.
There is. Really kind of pissed off that I might tell you about, let the world know that
you need to get a new.
You know how California? I do have a new microphone. You can't hear me?
You
I can hear you good now.
You keep going in and out.
China is buying Californian water, and Californians are doing without.
Yeah.
That's real. They use all the water for fracking.
I'm not trying to be rude, but you do know that this is capitalism coming to bite you in the ass, right?
No.
And you do know that China is buying all the land around all the military bases in the United States, right? And you did know that China is buying gold mines and all kinds of.
And they're sending over what?
I
don't know,
world, right?
2 million military-age troops. They don't have to go look for weapons. They can buy it with their credit card.
Yeah.
Thanks, America.
They're selling all of our water.
Well,
hey,
don't worry.
You're lucky that we let our water go near your border. Okay, if we could stop the water from going across the border like the Rio Grande, we'd have you guys nailed. But no.
Greg, don't worry. We sold all our water to you anyway, long time ago.
No, we didn't.
Yeah, we did. We sold the rights to it.
No, we haven't.
The Americans have the right to our water.
No, they have right to one aquifer, which is underneath the Lake Michigan, which they own the majority of.
If George Washington would have supported Benedict Arnold, Toronto would be part of the United States.
Yeah, well, if we decide to finish the job in 1814, you would be part of the British Empire. So there you are.
Whatever happened with Canada? You guys just kind of like slipped in there.
Do you really want me to tell you exactly what happened?
Yeah.
It's really straightforward. You know that thing that you did to North and South Korea, North and South Vietnam, and East and West Germany, and all that kind of shit that you do, where you divide a country into two? Well, that's exactly what they used to do. Like you learned that from the English and the French, who used to go in, divide a country up, and make them fight each other. Well, this is that situation. The English the French wanted to move ahead. You guys were getting uppity. They helped you and said, here's a bunch of troops, here's a bunch of things, here's how you get your membership, here's a bunch of boots, here's a bunch of everything that you need to do your fighting. And they trained your troops, and it was basically France versus England during part of their 100-year war. The only difference is that instead of being able to continue, France and King Louis XVI got his head chopped off, along with a lot of people. So during the head chopping good times, there was no one who wanted to go and continue that thing that they were doing all the time. So basically, it stopped, and you guys were like, you guys were free. But I mean, you still honored the people like General Lafayette and all the people who helped you. I hope George Washington, but most people don't know it even happened, that the French had anything to do with what you were doing. And then because the French and the British were basically having a war with each other on your territory. You were the Vietnam this time.
Yeah.
That's what it was. If you think about
the Indians ganged up to try to take us out.
Wouldn't you?
Some Indians were on our side, and some Indians were on theirs.
But the British didn't break their word with the natives, even to this day. No, I mean, not pay them directly like that. I mean, they self-govern their own places, but we provide money per year to rent from it, like for rent from them, and we've just maintained that thing. The trouble is, in a lot being self-governed, they can just basically, the chief can give all his friends new trucks. He doesn't have to do anything. So basically, it's sort of like a shitty situation that we often get blamed for, because we can't exactly go and override their rights.
What is your situation in Canada with immigration? Is it off the hook like it is here?
Oh.
It depends on who you ask, but things because of the like, we're getting a lot of immigration from like Bangladesh, the Congo, a bunch of other places too. But
a million people last year.
But as much as Sarah and people like me might argue, the one problem is, like, we all came here from somewhere else. Like I said, look, I'm Scottish Irish. We came over at this time. This is when we arrived. You know, this is how we got land. This is how this all happened. They gave them 40 or 50, 100 acres. So what are you talking about that we didn't get anything? Like, they did. You know, so I'm trying to say, adapting to our culture is not hard. It's pretty laid back. And obviously there's some people who are not happy because there's so much. But to be perfectly honest, if we don't get more, we're going to start decreasing in population. We're just not having the amount of people that we need to maintain growth. And unfortunately, this has also caused another problem too, because we're letting some idiots, in a way, basically do what's happening to your country, where a bunch of Chinese people are biting up all the land.
Nobody wants to live in the cold.
Let's just say, I hope the CIA and CSIS are both paying attention to that.
Well, you know, as far as buying land, the U.S. can just do to the Chinese or whoever they are, just like they do to Americans, and say, eminent domain, we're taking it back, it's ours.
Yeah, but what if what if they have plans, including like on this date, on this thing, you go.
I guess it's over, folks. Hold on a sec. That's going to do it for tonight. I'm going to play another couple videos for further reference, but I thought that was a very engaging conversation that we had, and I'm looking forward to having more, for sure. And leave a comment, let me know what you like, let me know what your interests are. I'm not done, I'm going to show something. And then I might go, but I'll come back with a totally different slang. Hold on.
Kina. In the tractate Brakat of the Babylonian Talmud, it is said that the deluge was caused by two stars that fell from Kina toward the earth. The statement reads, when the Holy One wanted to bring a flood upon the world, he took two stars from Kina and brought a flood upon the world. Now, I have already mentioned that Rashi, the medieval exegete, whose authority is unsurpassed among the rabbis, says that in the quoted sentence, Kina means a star with a tail, or a comet. This explanation found its way into the works of several Gentile theologians. Should it be understood so that two large meteorites fell from a comet and falling on Earth caused tidal waves? Instances when meteorites fell while a comet was glowing in the sky are known, and the classic case is found in Aristotle. Should a meteorite equal in mass to one which, by its impact, formed the Arizona crater, fall into the ocean, tidal waves of a wide spread would result, possibly circling the globe. Then are we to understand the deluge as a huge tidal wave rushing across the continents? This picture differs widely from the story in Genesis, according to which water was falling for a long period from the sky and the waters of the depths rose, covering the surface of the earth. And the tractate Brakat so explicitly points to the cause of the deluge that before classifying the narrative in Genesis in its entirety as folkloristic imagery, which imparted most certainly is, and also before following Rashi's idea any further, we ought to inquire which celestial body is Kina. Is it correctly explained as a comet? It's mentioned in several instances in Job chapter 9, The Lord is he who removes the mountains and overturns them, and shakes the earth out of her place, which commands the sun, and it rises not, which alone spreads the heaven, which makes Aish and Kessel and Kima and the chambers of the south. In the King James Version, these names are translated as Arcturus, Orion, and Pleiades. Chambers of the south are usually explained as constellations of the south. Kima and Kessel are also named in Job chapter 38. Here again in the text that deals with the violent acts to which the earth was once subjected. Who shut up the sea with doors, barriers, in parentheses, when it brake forth as if had issued out of the womb? Who might take hold of the ends of the earth, that the wicked might be shaken out of it? The Lord asked Job, Canst thou bind the chains, fetters, of Kima, and loosen the reins of Kessel? Canst thou lead forth the Mazaroth in its season? Davidson and Lancaster wonder at the meaning of this passage. Like the King James Version, they translate Pleiades for Kima and Orion for Kessel. Mazaroth is left untranslated. In Amos chapter 5, once more, Kima and Kessel are mentioned in a verse that reveals the great acts of the Lord, who makes Kima and Kessel, and turns the shadow of death into morning, and makes the day dark with night, that calls for the waters of the sea, and pours them upon the face of the earth. Hieronymus, also known as Saint Jerome, the 4th century author of the Vulgate, the Latin version of the Old Testament, translates Kima as Arcturus. In one instance, Amos 5, as Pleiades, in another, Job 38, and as Hyades in the third, Job 9. Similarly, Kessel was translated by the Septuagint, the Greek version of the Old Testament that dates back to the 3rd century before the present era. I didn't realize there were so many versions. As Hesperus. Arcturus in the Vulgate is rendered as Pleiades by the Septuagint. Obviously, the true meaning of these names was lost, because one and the same authority in various instances used different star constellations or planets for each of them. Kessel, Kima, Mazaroth, Aish, later interpreters groped in the dark. So Calmet, the eminent French commenter and exegete in the early 18th century, translated Kima as Great Bearer. Others rendered it as Sirius, Canis Major. The interpreters were especially intrigued by the description in Job 38. The Lord asks Job whether he can bind the chains of Kima or loosen the reins of Kessel. The word in the second clause is from a root always meaning to draw. Which star is in chains, and which star is drawn by reins, as if by horses? The identities of Kima and Kessel, Aish and Mazaroth, were of lesser importance when it amounted to finding their meaning for their own sake in poetical sentences of Amos and Job. But such identification, especially of Kima, grows in importance if the quoted sentence from the tractate Brakat may contribute to an understanding of the etiology of the deluge, as the ancients knew or thought to know it. In Worlds in Collision, I have already explained that Mazaroth signifies the morning, evening star. The Vulgate has Lucifer for Mazaroth, and the Septuagint reads, "Canst thou bring forth Mazaroth in his season, and guide the evening star by his long hair?" I have already shown why the morning-evening star was described as having hair or coma, and why Venus did not appear in its seasons. Apparently, the other members of the group were planets too, and actually, we could have started by the disclosure that in the rabbinical literature, Kima is referred to as Mazel Kima. Mazel means planet. Then, which planet is Kima? If we can find out which of the planets is Kima, then we may know also to which planet the Talmud assigned the physical cause of the world inundation. As we have seen, the biblical texts by themselves do not contain the means to determine which of the planets Kima and Kessel are. Were it not for the heat of Kessel, the world could not endure the cold of Kima. Were it not for the cold of Kima, the world could not endure the heat of Kessel. This sentence is found, too, in the Babylonian Talmud, in the Tractate Breakup. Kessel means fool. From the biblical texts, it is not apparent why one of the planets received this adverse name, or why, more probably, the word fool was derived from the name of a planet. In the Iliad, Ares Mars is called fool. Pallas Athena said to him, "Fool, not even yet hast thou learned how much mightier than thou I avow me to be, that thou matchest thy strength with mine." These words explain also why Mars was called fool. It clashed repeatedly with the planet comet Venus, much more massive and stronger than itself. To the peoples of the world, this prolonged combat must have appeared either as a very valiant action on the part of Mars, not resting, but coming up again and again to attack the stupendous Venus, or it must have appeared as a foolish action of going again and again against the stronger planet. Homer described the celestial battles as actions of foolishness on the part of Mars. Thus, Kessel, or fool, among the planets named in the Old Testament, is most probably Mars. In Pliny, we find a sentence which reads, "The star Mars has a fiery glow, owing to its excessive heat and Saturn's frost. Jupiter, being situated between them, combines the influence of each and renders it healthy." The heating effect ascribed in the Talmud to Kessel is ascribed by Pliny to Mars, and the cooling effect of Kima to Saturn. By this sentence of Pliny, we are strengthened in our identification of Kessel as the planet Mars. It corroborates the conclusion we just made with the help of the Iliad. But what is even more important, Pliny helps to identify the planet Kima. It is Saturn. Cicero also wrote that Saturn has a cooling influence, whereas Mars imparts heat. Porphyry, the author of the 3rd century, wrote similarly with Pliny and Cicero. The power of Kronos, Saturn, they perceive to be sluggish and slow and cold. The power of Ares, Mars, they perceive to be fiery. Porphyry's contemporary, Plotinus, wrote, "When the cold planet Saturn is in opposition to the warm planet Mars, both become harmful." Other statements to the same effect are found in Vitruvius and Proclus. In these sentences, as in those of Pliny and of the Talmud, Mars is regarded as being a fiery planet, Saturn as being a cold planet. The passage in the book of Job 38:31 can now be read. "Canst thou bind the bonds of Saturn and loosen the reins of Mars?" The bonds of Saturn can be seen even today with a small telescope. The reins of Kessel I discussed in Worlds in Collision section The Steeds of Mars. 2 small moons of Mars, Phobos and Deimos, were known to Homer and are mentioned by Virgil. They were regarded by the peoples of antiquity as steeds yoked to Mars' chariot. The passage in the Talmud makes the planet Kima responsible for the deluge, means 2 stars erupted from the planet Saturn and caused the deluge. And there are your references. Saturnian comets. Before searching ancient traditions for any possible association of Saturn with the deluge, let us notice that the idea that Saturn may have anything to do with the origin of some of the comets of the solar system is not without a theoretical foundation. A group of short-period comets carries the name of the Saturnian family of comets. They revolve on ellipses that approach closely. A larger family of short-period comets carries the name Jovian, and Jupiter is regarded as having something to do with their origin. Their orbits come close to the orbit of Jupiter. The usual explanation for the Saturnian and Jovian families of comets is that they had originally traveled on extremely elongated or even parabolic orbits and passing close to one of the large planets, were changed into short-period comets, traveling on ellipses. It is usual to say that they were captured. However, the Russian astronomer K. Vishatsvyatsky of the Kiev Observatory, one of the leading authorities on comets, has brought strong arguments to show that the comets of the solar system are very youthful bodies, only a few thousand years old, and that they originated in explosions from the planets, especially from the major planets Saturn and Jupiter, or their moons. By comparing the observed luminosity of the periodic comets on their subsequent returns, he found it failing, and their masses rapidly diminishing by loss of matter to the space through which they travel. The head of the comet emits tails on each passage close to the Sun, and then dissipates the matter of the tails without recovery. Thus, Vishatsvyatsky concluded that comets of short duration originated in the solar system, were not captured from outside of that system, a point to which the majority of astronomers still adhere, and that they came into existence by explosion from Jupiter and Saturn, and to a smaller extent by explosion from the smaller planets like Venus and Mars. In order to originate in this manner from a planet, the exploded mass must overcome the gravitational pull of the parent body. The larger the mass of the planet, the greater must be the initial velocity of the exploding matter, the velocity of escape. For this reason, the idea of explosion of comets from the planets is preferred to the idea of their explosion from the Sun. Due to the great mass of the Sun, the velocity of escape from there must be in the approximation of xxx kilometers in the first second, and from Saturn, only 35 kilometers. But even these velocities are rather high, so that Professor Vishatsvyatsky acknowledged there must have been unusual circumstances, which he did not try to determine, but the existence of which he claimed on a basis of the effects produced, namely the short-lived comets reaching to the orbits of Jupiter and Saturn. Every time these comets recede from the Sun to their furthest points, aphelia. The sentence in the tractate Bracot that ascribes the cause of the deluge to the cometary bodies that erupted from the planet Saturn no longer appears as fantastic as when we first understood the meaning of kina in that sentence. The explosion of cometary bodies from Saturn and Jupiter is claimed on the basis of purely astronomical observations and calculations. The circumstances of such explosions must have been admittingly extraordinary. The time when this happened must be measured in thousands of years, not tens of thousands or millions. Will we also be able to establish, with the help of collective human memory, what were the extraordinary conditions? But should we not first, as intended, place ourselves on firmer ground by showing that the statement in the tractate Bracot is not a lone testimony unsupported in the traditions and beliefs of the ancient races of the world. Saturn and the Deluge. Following the rabbinical sources which declare that the deluge was caused by two comets ejected by the planet Kina, and our interpretation of the planet Kina as Saturn, we begin to understand the astrological texts, such as certain passages in the
Tetrabiblos
of Ptolemy, which attribute to the planet Saturn floods and all catastrophes caused by high water. The planet's presence in Aquarius, especially, brought expectations of heavy rains and flooding, as is attested, among others, by the 1st century Roman author Lucan. Many of the ancient astrologers were in agreement on this point. In a work entitled Speculum Astrologiae, Tontinus ascribes inundations to the action of Saturn's comets. Cuneiform texts contain prophecies of a deluge taking place when a comet assumes a direction with its head towards the Earth. Philosophers of antiquity who were not astrologers also expressed their belief that Saturn is in some way related to moisture. Among them, the pre-Socratics Philolaus and Philodemus, and somewhat later, Plato. The elder Pliny wrote in his natural history that is well known. Heavy rains follow transitions of Saturn. Servius asserted that Saturn is a god of rains. When in the sign of Capricorn, he causes very heavy rains, especially in Italy. And again, Saturn is the god of all that is humid and cold. Proclus recorded the beliefs of the Pythagoreans. Again, in the heavens, Aries is fire, Jupiter air, Kronos water. Nonos referred to the heavens. Aries is fire, Jupiter air, Kronos water. Ancient Kronos, heavy need, pouring rain. Hippolytus wrote of the beliefs of a member of the Parate sect. But water, he says, is destruction. Nor did the world, he says, perish by any other thing quicker than by water. Water, however, they assert it to be Kronos. We recognize that the astrological connection between Saturn and catastrophes created by high water has a very ancient origin. In the Chaldean story of the deluge, as told by Berosus, Kronos, Saturn, disclosed to the king Xisuthros that a universal flood would begin on the 15th of the month. Dacios Abydinos says Kronos announced to Xisuthros that a flood would pour from above. A few more things for you. Those are
terminals that refuse to turn off. I'm not through with you yet, darling. I have more in store.
Therefore, all of their ways of understanding things are tailored to that. And they don't come in with the possibility that this other...
Dr. Arp was forced to resign of Quasars. Halton C. Arp has for 35 years proposed just such an idea.
If you think
For the
that
heresy of
academia
opposing
is
orthodox
fair
interpretations
and
of the
only
redshifts
absolute
problem,
truth,
Arp has had to pay
you
a
really
heavy
need to
price.
see this.
The same price paid by many
Because it
scientists with
reveals
new
how they
and
really
innovative
are.
ideas. Dr. Arp was forced to resign from his permanent position at the Carnegie Institute of Washington Observatories after the Caltech head of the Telescope Allocation Committee threatened him by saying, unless he changed his line of research, they would take away his telescope time. Due to this fact and his ongoing struggle against the established paradigms, Arp is often referred to as the modern Galileo.
I remember when I sent the paper into, the first paper into Astrophysical Journal on the nature of companion galaxies, and I had a lot of them on the ends of spiral arms, so I was sure that they were connected, and I showed that they were systematically redshifted. I sent that in with naive, great expectations that people would be terribly interested and impressed on this. And the editor of the Astrophysical Journal at that time was Subrahmanyan Chandrasekhar, who had a fantastic reputation as a master theoretician and also quite an incomprehensible theoretician, and a tremendously powerful figure in the field, and editor of the Astrophysical Journal, which is probably the most powerful position in the field. And he chose not to, in his wisdom and judicial fairness, chose not to send it to a referee, but he just wrote across the paper, "This exceeds my imagination," and he sent it back to the director of my institute, Horace Babcock, with the obvious implication, you've got to do something about this staff member of yours who's doing these very bad things. And so Horace called me down in the office one day after this, and I walked in his office, into the director's office, and I saw this paper lying in front of him with Chandrasekhar's scroll across it. And Horace looked at me and said, well, he said, this is just too much, and you're going to have to start looking for another job. And so all I could say to him was, well, if you send me that in writing, please send me in writing. And I was waiting in great trepidation for weeks and months to get something in writing, and I finally never did, so I realized that he decided to give me another chance, so to speak. So that was fairly early in the game, and then some years went by, and there was the competition for time, particularly on the 200-inch telescope, was getting more and more heated, and people were saying, well, we can't continue to give time to this obviously incorrect and embarrassing research that ARP does. So finally they sent a letter to me from the allocation committee, including a number of the younger members of my institute, saying that unless I changed my line of research, that they would have to take away my telescope time. At that point, I considered the situation very carefully, and I figured that the evidence, although a lot more evidence could be gathered and has since been gathered since then, the important thing was not the evidence, because if it was true, it would come out someday. The important thing was the principle of scientific investigation, whether scientists could follow new lines of investigation and follow up on evidence which apparently contradicted the current theorems and the current paradigms. And I also felt that regardless of what happened to me personally, that this was the important issue. And
just to add my 2 cents, make it add up to $1. This kind of stuff goes on daily, weekly, monthly, yearly, and we never hear about it. But this is the reason, one of the major reasons, why the world is upside down. The science that people believe is science, the hoax.
And that I had no choice but to resign on the point of this issue, so that if it developed, which I thought it would, that my line of investigation was correct, that people then in the future would say, okay, this was the wrong thing to do, and in the future we're going to have to see that this kind of thing doesn't happen again.
The observers come in now with the belief that we live in a Big Bang universe, and therefore all of their ways of understanding things are tailored to that. And they don't come in with the possibility that our alternative, or any other for that matter, is right, and really do it in an open-minded way. And of course what goes along with that is that observers who would like to test this way find it very hard to get observing time and so on. I mean, this relates to the whole issue of whether the complete lack of balance in the way the observational programs and the funding are conducted. There's no question about that. I don't think that anybody would argue about it.
I've always said that the cause of the troubles is the American graduate school. You get one person who then lectures to his students in graduate class, and because you have a system, you see, when we had graduated first degree, we were independent. We could thumb our noses at the professor, and in fact the best way to get ahead was to do something that the older people didn't agree with. To be right, that was the way to do it. And but in the graduate school, you all have to learn what you're taught, what the professors are teaching you, and then those people go out and get jobs, and they have another graduate, their own graduate school, and it just tier after tier. You get a few places like Caltech or like Harvard, and they set the fashion for every place.
I think there's a problem with graduate education. I think
Imagine if every puzzle on Earth was solved, every why that we have pondered but could not answer for all our trying be mastered. Imagine if we all, God's ways, could clearly understand. Will this be reality, or is it just myth? Our thinking is like the streaming colored lights, flames flickering across the dark northern night. It was dark before we started thinking, and it will be dark again if we stop. Some claim that most questions in nature have been answered. Others think that we have only just begun asking. This is their story, the story of the universe.
Plasmas are found virtually everywhere. They're found in solid state matters at very low temperatures. A flame of a match, a fluorescent light is a plasma. Fire in your fireplace is a plasma. The aurora obviously is a plasma. The sun and all of the stars are a plasma. Lightning is a plasma. In fact, 99.999%, as Alfvén used to say, of all observable matter in the universe is matter in the plasma state.
A plasma is an ionized gas. It means a gas consisting of charged particles rather than neutral particles, which is the constituents of a normal gas. The charged particles are electrons and atoms that lack electrons. So it consists of negative and positive particles that interact with each other by means of electric and magnetic fields.
The term plasma, as applied to electromagnetics, was first coined in 1923 by the Nobel laureate Irving Langmuir to describe the experiments that he was doing at the time. Basically, plasma consists of charged particles, the electrons and the ions or protons that we know in nature. It can also include charged dust. And in Irving Langmuir's experiments with the charged particles, he noted that they acted almost in a lifelike manner. They tended to develop cells. They acted very much in a way that indicated that they might somehow be related to life. And for that reason, he borrowed the term plasma from the blood plasma.
A plasma is like a society of individuals where all the individuals are interacting with each other through complex interactions like media, newspapers, television, and so on. And the normal gas is like a society where the individuals simply basically don't interact or interact at very short distances, very local communities.
The first effort to understand how plasma functions in the universe, to understand the plasma universe, was Christian Birkeland, who at the end of the 19th century wanted to understand what is the nature of the aurora.
Birkeland became interested in the aurora at the beginning of the 1890s, and it was, without a doubt, due to his work with cathode ray tubes. Cathode ray tube is a vacuum chamber with an electric current, so when the air pressure gets low enough, current passes through. In Birkeland's day, they didn't know there was a current because electrons hadn't been discovered yet. But in any case, Birkeland found an analogy between the cathode ray tubes and what he had observed on the sun.
We're studying for the first time the nature of electrons. And you had, for example, the development of the cathode ray tube. The cathode ray tube we're familiar with. This is what powers our computers and our television screens. You have electrons accelerated, smashing into phosphorescent atoms in the screen and producing light.
Already before this time, Birkeland believed that cathode rays came from the sunspots and struck the Earth, creating the auroral displays. This connection between the sun and Earth had been around a while, because scientists were aware that when powerful solar explosions were observed, for example, like the one in 1859, that a powerful magnetic storm was also observed on Earth afterward. And because of this, Birkeland concluded that the sun and Earth were connected, and that cathode rays were the cause, and also that there must have been an electric current between the sun and Earth that sent the rays.
Some people have said that science is a method for asking questions of nature. And if that's true, then we can say the Big Bang supporters are people who won't take no for an answer.
Over the last 2 or 3 decades, the Big Bang theory has become increasingly more and more speculative. One expects from a scientific theory definite predictions which can be tested by observations. If the observations disprove the predictions, the theory is supposed to be disproved and it should be modified or abandoned.
In science, we work from observation, from empirical observation that starts in the here and now and works outwards and backwards. The Big Bang starts from mathematical formulas, deductions that start from the beginning of the universe and to try and predict it forward. This is the same mathematical approach, mathematical deductive approach, that led 2,000 years ago to the development of the Ptolemaic universe. The universe, of course, which was Earth-centered, with the planets going around the Earth, with the stars in a crystalline sphere. What these theories have in common is that they try and derive what should be the universe based on what perfect principles we can develop, what God should have made the universe to look like. And then they try to fit the universe into that perfect framework.
However, what has happened over the years is that whenever observations have come up which don't agree with the predictions of the Big Bang theory, the theory adds an extra assumption which is not at all tested, which is not at all resting on conventional physics, and simply assumes that that must be true.
The problem with that is that develops myth, not science. It develops a religious faith in which nothing
all mainstream science
in the real world, in the observable world, can contradict the faith in this structure, in the Big Bang. This undermines the entire scientific enterprise. The reason science has been valuable to human beings is because it allows us to predict nature in such a way as we can use nature in a predictable fashion in technology. To abandon this approach, which has served us so well, and to go to the idea that we can deduce, we can read the mind of God, as Stephen Hawking says, and deduce from perfect mathematical principles what the universe must be, is to abandon the scientific method.
In standard Big Bang cosmology, you have what I call a series of epicycles. The Greeks used to have epicycles, which are known as circles whose centers move on other circles, whose centers move on other circles, in order that they could correctly describe the position of a planet at any given time. They found that in some cases they had to introduce many circles before they could get anywhere near the reality. These epicycles are the assumptions that have been put in ad hoc into the theory from time to time.
It's very smart matter. What was dark matter? Dark matter was some matter that we don't understand, we don't know what it's about, we haven't observed it, but it isn't ordinary matter, so it doesn't enter into our equations about the light elements, and we can't see it as stars. But dark matter is 90 or 99% of the mass of the universe. This is what we call in science a fudge factor. When your equations don't work out, you just write in this little plus something. Well, in this case, this was a humongous fudge factor because it was 90 or 99% of the universe.
It's like the U.S.
And
government.
you have to not only postulate that this matter has to exist, but it has to exist in quantities much greater than the amount you see of ordinary matter.
And I should emphasize that people have looked for dark matter. People have looked for dark matter since it was proposed 20 years ago. axions, WIMPs, little particles that are supposed to be floating around in space, that we should, in theory, be able to observe as they pass through the Earth. Dozens of experiments have looked for these particles. Not one has been found. Again, this should be a contradiction. The way science works, you make a prediction, observation contradicts it, the theory should be rejected. But that hasn't happened. And the epicycles don't end. There's a problem with dark matter, even theoretically. Even though we can't observe it, there's still a problem with it, which is dark matter slows down the expansion of the universe. So the length of time that the universe has existed, the length of time since the Big Bang, should be shorter than what's indicated just by linear expansion. Well, the problem is it's too short. Prediction of the cold dark matter theory is that the universe should be about 8 billion years old. Well, that's a big problem. We can determine the age of stars in our own galaxy, in the oldest globular clusters, both based on very well confirmed theories of the nuclear evolution of stars and spectroscopic observation. And the stars in our galaxy are 13 or 14 billion years old. So it's very embarrassing to have 14 billion year old stars in an 8 billion year old universe.
In addition, they went into dark energy. Now, why did dark energy come in? Because if you take the present value of the cosmological constant and the cosmological constant which came out of inflation, you find that they are not the same. Not only they are the same, but you have to find that the difference lies in something like 108 orders of magnitude. Now, can you imagine a physical theory getting the answers wrong by a factor 10 to the power 108? Yet, the Big Bang cosmologists very coolly accept this and simply put in another epicycle by saying that there is a dark energy which has changed over the time by this factor. So we have to accept that.
Dark energy is some force, again, unknown on Earth, unpredicted by any theory that we have validation of here on Earth, that causes an acceleration of the expansion of the universe. So as the universe is accelerating, and it's older than appears on the basis of the dark matter theory, and it's 15 billion years old. So we solve the problem of the age of the universe by hypothesizing yet a third completely ad hoc epicycle dark energy. So now we have a universe which is 70% dark energy, 28% dark matter, and only 2% matter that we can observe through our telescopes and here on Earth. Epicycle is being piled onto epicycle. And in the process, what we call the predictive power of the theory is fading away to nothing. One of the most destructive features of the methodology of the Big Bang is that it conveys the idea that only experts can understand the universe. Only people versed in extremely complicated mathematics can understand the universe. That if dark matter, dark energy appear to be incomprehensible or even nonsensical, it's because you don't understand the mathematics of these complex equations. This is, of course, the argument of the emperor's new clothes. If you can't see the emperor's new clothes, then you must be either stupid or incompetent.
So this goes on, and we can find that the old Greek tradition of epicycles, which was even adopted by Copernicus and has been continuing in standard Big Bang cosmology. If we go by the history, the Keplerian orbits, which were elliptical orbits, very cleanly and neatly resolved the problem of planets. And the circles upon circles idea had ultimately to crumble down. Now, in the same way, I suspect that the Big Bang theory will collapse under its own weight of assumptions, and a more neat theory, neat interpretation of the universe will emerge.
Does this mean that the age of the universe is not what Big Bang theorists have implied? Could the universe be eternal after all? How much are cosmologists really able to know?
We are now in a stage which can be called a plasma universe. And we are simply not privileged to know what stage the plasma universe evolved from. We do not have privilege to that information. We do not know. We will never know. And this is one major difference between the plasma universe cosmology and the Big Bang cosmology that claims to be closing in on the final answer.
The universe described by plasma cosmology is quite different. Here we are talking about a universe with no beginning and no end, an infinite universe, continuously evolving, an evolution that is continuously increasing at an ever-rapid pace. It is a universe in which there is a coherence between what we can understand in the here and now on Earth and what we can understand in the rest of the universe. A universe in which there is no real limit to our ability to understand more new phenomena. And a universe in which we can apply what we learn in the universe in present-day technology.
The basic difference between plasma and all other forms of matter, that is solid liquids and gases, is that a plasma produces electromagnetic radiation and also tends to filament. So that we would expect in a simulation, which is what we see, in an experiment, which is what we see, we would expect to see throughout the cosmos a filamentary structure that is a spaghetti of currents intertwining the cosmos.
We can use plasma theory derived from experiments in the laboratory, from the basic concepts of plasma instabilities, from Maxwell's equations, and from the well-known laws of gravitation, to describe and predict how the structure of the universe came into being and what that structure is. So the key question is, how could this structure come into existence? Now, in the Big Bang theory, the universe starts out extremely homogeneous, very smooth.
This was in direct contradiction to the plasma universe that insisted that the universe overall must be filamentary.
But what we have today is extremely clumpy matter. When I talk about these huge voids, the structure of voids, the matter inside the voids is less than 10%, perhaps less than a few percent as dense as the average. And the matter in the walls of these voids, where these filaments of superclusters of galaxies are located, is 10 or 20 times the average. So you have extreme clumpiness. Now, what's the problem for the Big Bang to explain this? There's a huge problem. There is not enough time since the Big Bang to form these structures. These structures are older, much older than the time hypothesized since the Big Bang.
Now, again, in interpreting the observational information, we can again go to the laboratory, which we are privileged to diagnose in any number of ways, in any number of directions, and run any number of experiments, which you can't do with the universe. But we also turn
almost
to
look
the
like two little
supercomputer,
living creatures.
Simulations. Now, what a simulation does is that it allows you to model the plasma, regardless of size, put in the rather few basic initial equations, and then follow the simulation through its various nonlinear stages and the different morphologies or shapes that the plasma will take.
In Tony Peratt's simulations, as the current spirals into the center of the galaxy, turns around and moves out along the axis of the galaxy. In that central area where the current is extremely concentrated, there seemed again the potential for violent events. And Alfvén and Peratt raised the question, couldn't this be a way of explaining the extremely violent events that occur in the center of galaxies that are known as quasars, in which huge amounts of energy are released in what, by astronomical terms, is a relatively small amount of time. That is, millions of years compared with the billions of years galaxies exist.
Initially, the time frames shown represent 1 billion years or so, but now we're going to carry it out for 10 billion years to see what happens to these double radio galaxies or quasars as the two filaments have evolved into. And you'll see that the tails start to elongate, and fairly soon you're going to start to see a spiral structure. And as we get closer to 10 billion years, the end of the movie, you will see that we have formed the shape, the morphology, the shape of a spiral galaxy.
Now, Alfvén developed a number of concepts that were critical to the whole understanding of the plasma universe. First of all was the basic concept of scale invariance in plasmas. That means there are certain phenomena in plasmas that don't change regardless of whether you're dealing with a laboratory scale of centimeters or a solar system scale of millions of kilometers or a galactic scale of hundreds of thousands of light years. What that meant was that time scales the same way as distance does. So not only does this mean that the phenomena of the cosmos can be studied in the laboratory, but because of time compression, phenomena of the cosmos are essentially transient phenomena. It's funny to think of a galaxy lasting billions of years as a transient phenomenon, but it's analogous to events in the laboratory that last only millions of seconds. Another way of putting it, the plasma universe is extremely dynamic.
It's not going to be hypothesis. We've moved further than hypothesis. We've definitely gone into the second lake, the analysis, and we're well towards the third lake. Now, we haven't reached the third lake, of course, and perhaps, well, you can't with the universe because you can't experiment with the universe itself. Now, of course, we, like Alfvén, his idea, indeed you can determine what's happening in the universe in an experiment, but as far as producing universes, well, we're not going to do that. So we're going to do the best we can in the laboratory.
The universe that the Big Bang envisions and the universe of plasma cosmology are very different universes, and they have very different implications, and they cohere with very different ideologies of what is happening here on Earth.
The Big Bang theory will collapse under its own weight of assumptions, and a more neat theory, neat interpretation of the universe will emerge.
Again, of the kinds of things I said in 2001, to give you a refresher on the electric universe model that I'm proposing, and then to talk about how that might fit with the kinds of things that have been uncovered by the comparative mythologists in the US, Dwight Cardona, Dave Talbot, Ev Cochran, and others. And it's, of course, just my view, and it seems to make sense to me, but it may not make sense to you, and I'm quite happy to discuss the sense or the nonsense after I've spoken. This slide I used to open the conference presentation in Amsterdam. I tried to gauge the audience's reaction to it. I said, does this send a shiver up your spine when you look at it? Because in this picture, Mars is about 100 times closer to the Earth than its present closest approach at about 15 million miles. The image is superimposed with plenty of lightning and so on at the Kitt Peak Observatory. And of course with that well-known quote. This is the book, or the first book in a series, which is available on our website, thunderbolts.info. And it's the first few chapters of a series. The second in the series will be the electric universe. But this one is a kind of introduction, and it also features some of the work of Tony Peratt, who I'm very pleased to say is in the audience and will be speaking after me. Both David Talbot and myself got our inspiration initially from Immanuel Velikovsky, who threw down the challenge to science of the day by proposing that electromagnetism had a role to play in the dynamics of the solar system. Of course, we all know what happened. It was many years later that I finally came to the big picture view, if you like, that electricity is at the heart of everything. In other words, all matter is made up of charged particles, and that their interactions at all scales is what gives the complexity and the wonders of the universe that we observe. The idea is, and this is rather heretical, this is supposed to represent a hydrogen atom with the nucleus appropriately placed here, and the electron shown to have structure. In other words, an electron is not a fundamental particle, it is a composite particle made up of subunits of charge. Now this idea came from Ralph Sansbury, who has been to some of our meetings and who I'd like to see along again. One of the requirements of this model is that these electrical particles are able to communicate at near infinite speed. Otherwise you cannot form stable systems of particles. You cannot form stable electrons, protons, neutrons. In other words, we wouldn't have the universe we see today. But of course, if you talk about communication at near infinite speed, you then have to worry about Einstein and the things that are believed as a result of his work. And in fact, you have to give Einstein's theories or his interpretations of the mathematics a miss and look at it all again. Of course, this kind of communication between these subparticles within normal matter has meaning for biology too, because it means that every complex system of atoms will have a kind of a resonance about them which is communicated to nearby and even distant molecules of the same configuration. So in other words, you start to see how the mind-body connection might work. And you get the impression also that the idea that nerves carry the signals around the body about what is going on in the environment is totally inadequate. I mean, nerve signals travel at speeds measured in meters a second. If we have all of the mind and the body connected at near infinite speed, we begin to understand how the amazing complexity of consciousness and so on may work. When we go from that level, we go up to space and we're looking at the interaction of charged particles in plasma. And this, of course, is Tony's area of expertise, and we'll hear about some of the amazing formations that plasma can adopt. So that's a very quick vision of how it works at the most fundamental level. In the big picture approach, of course, there are many aspects which have to be plugged in and fitted like pieces of a jigsaw puzzle. So it embraces plasma cosmology, because I think that's the most complete description of what's going on in space. It embraces Halton Arp's discovery of the birth of galaxies in the form of quasars from the centers of active galaxies. This electrical model of matter, the structure of matter, also explains gravity and magnetism, because if you have these charged particles in an electric field, they will be distorted and form tiny electric dipoles. One form of the dipole at the atomic level creates magnetism, Gravity is the distortion of the subatomic particles themselves, the electron, the proton, the neutron. That explains why gravity is such a weak force, because the distortion of these subatomic particles is absolutely minuscule. Quantum weirdness now has an explanation. Instead of using probabilistic mathematics to describe what goes on in the world, and I'm reminded of Douglas Adams with his infinite improbability drive. You know, with that kind of mathematics and underneath your physics, it means that almost anything can be said and explained away as being, well, you know, there's a finite probability that it will occur. And I think that's hopeless physics. If you give this substructure to matter, you then have the possibility of explaining quantum effects, that is, jumps from one energy level to another, as simply jumps from one resonance state to another. Of course, that discards certain things along the way. If you take this view, genetic determinism goes away because we're in contact with something outside, beyond the body. It also, the plasma physics view also shows us that we have a dramatic history of the Earth. It's nothing like what we believed before. And it seems to be offering a coherent big picture, because all of the discoveries that keep pouring in almost on a daily and weekly basis have no trouble in fitting this model, as far as I can see. And I'm also encouraged by others who look at this theory and then look at the news reports and come to me and say, well, you know, it makes sense. We come to plasma. On the screen there you see a simple plasma ball demonstration, which you've seen in novelty shops and museums. And you can see there that the electric discharge in the plasma takes a filamentary form. And if you look at the ends of the filaments, you can also see that they seem to be twisted pairs of filaments. And this is important. Well, plasma physics and plasma cosmology, in my view, are extremely important because plasma comprises almost 100% of the visible universe. Now, we live at the bottom of an ocean of atmosphere where we don't have to deal with plasma on a daily basis, although occasionally you get an electrostatic shock when you get out of the car and grab the handle and that kind of thing. But in space, the charged particles do tend to be separate and form this plasma, which then, unlike any solid, liquid or gas, which we're familiar with, it is conductive like a metal. It forms these filaments and bubbles and sheaths and has a magnetic field associated with it, generally if it's moving. Also, it can be recognized in space, even though it may be invisible to the visible spectrum telescopes. It produces prodigious electromagnetic radiation over large parts of the spectrum, which means that it can be detected by radio telescopes and, in intense examples, by X-ray and gamma-ray telescopes. You can almost see why we've gotten to this predicament of not recognizing the importance of plasma effects in space by the fact that we've grown up in this electrically, effectively neutral environment. But that's no reason to continue this way. Once we discovered plasma in space, then we should have been looking at electrical effects in plasma to help explain strange objects like this, the center of the Crab Nebula. Now that has all of the characteristics of a homopolar or a Faraday disk motor or generator. In other words, you have current moving along the axis and also in the plane of this disk. And we see this formation almost everywhere we look. Now, I sat in on the lectures. I didn't do the exam because I figured it was a waste of my time. But I sat through all of the lectures of the postgraduate astrophysics course at University of London. And at the end of the semester where we did plasma physics, I went to the lecturer and said, when do we cover the subject of electric discharges in plasma? And he said, we don't do that. I said to him, I think you're missing one of the most important aspects of cosmology. And he sort of turned on his heel and who are you? So astrophysicists aren't taught this subject. It's really in the realm of electrical engineering and the extreme end of electrical engineering, I think, as Tony would say. But it means that, in my view, the cosmology of the future will be open to the backyard tinkerer, because you can actually get out in the garage, and provided you do a little bit of electrical engineering, You can wire up high energy devices to create discharges and see what happens. You can use an arc welder to scar surfaces and then have a look at it under the microscope at what goes on, and then relate that to things that are being seen in deep space. Astronomers are not doing this. I talked about the twin filament or filament pairs that Birkeland currents, named after one of the pioneers of the electrical nature of the Earth and the solar system. And electricity tends to flow through plasma along magnetic field lines. So you're able to trace magnetic fields in space wherever the plasma is radiating, and it can be seen. So this double helix kind of arrangement can be seen in ejection of material from the sun, for instance. Of course, the astronomers say that it's magnetic effects that cause that. It's nothing to do with electric discharge. I was at a meeting of the National University where the director of the School of Astrophysics admitted that when we don't understand something, we blame it on magnetism. They were her exact words. As if magnetism did by magic. Now, we've already discovered these planetary Birkeland currents. Back in the 80s, there was an article in the New Scientist which was headed, "Soho catches Venus by the tail." Now, this is a distance of 45 million kilometres between Venus and the Earth, and the spacecraft here, Soho, discovered these strange stringy things. And there was no explanation for that, because it was felt that plasma from the tail of Venus would just blow and disperse like smoke in a wind. Instead of that, they found that it was kept into these very well collimated stringy things. And that's exactly what you'd expect of an electric current flowing from Venus away from the sun and impinging on the Earth. And this is important in how we achieve stability. I'll talk about that later. This is a very simple device which Tony knows quite a bit about. It's called the plasma gun, and all it is two cylinders of metal with an insulator between and a source of high energy, electrical energy. What you do is you fill a room with capacitors, charge them up, and then you have a special switch which you then throw, and the discharge begins at this end of these two cylinders and moves down this way. That's what this represents, the front of the discharge. When it gets to the end, it sort of balloons out of the end and then collapses back into the center of the inner tube and forms a tiny donut. And all of the energy stored in that huge array of capacitors is concentrated in a little donut about 0.5 millimeter across. Now, the electrons in that eventually get tangled up and the thing decays, but as it decays, it fires this intense beam of X-rays and particles along the axis. Now, this is a way of showing what happens when we concentrate electrical energy from a dispersed source down to a compact source. And in the universe today, we see repeatedly evidence of very compact sources of high energy radiation. And it's blamed on things like black holes, neutron stars, and strange things going on in the centers of active galaxies. All it is a concentration of electrical energy. This is looking down the barrel of the plasma gun, showing the Birkeland pair filaments radiating out from between the two electrodes. And this is the plasmoid, where the energy is collapsed in. It's only 0.5 millimeter across in this particular experiment. We look out into space, and this is looking down the barrel of a planetary nebula. Now, Charles Bruce, the English electrical engineer and fellow of the Royal Astronomical Society, picked these as being an electric discharge phenomenon back in the 60s, I think it was, or maybe even earlier. Here we have a very good comparison of this plasma gun effect with something that's seen in space on a much grander scale. Now, here's a stellar scale plasma gun, and can you imagine a jet like that extending from our star to 3 times the distance of Alpha Centauri? But this is what you've got. I've been to many meetings of the astrophysics department at the National University where they're spending an enormous amount of time and money trying to model these jets and explain how they punch their way out and still maintain that very fine collimation, and they haven't succeeded. But this is just a natural form of this plasma gun discharge effect.
The links to both of these videos will be accessible in the description. Strongly recommend watching the full videos to get the full amount of information that's available on this. I'm just touching on it. Follow up, and it will be worth it. Thanks for watching. Hello, folks. I hope you enjoyed the show tonight. It's getting to be about that time, and I just wanted to spend a little time with the chat room, which is something I rarely do. You know, I keep meaning to do something. You know, I don't have super chats. And I tell you, everyone I know that live streams with it really does good. You know, they do okay. But I don't have it, so I keep thinking, oh, I'm gonna copy and paste my information in the chat box, and I always forget. I can't get it now because the video is not going to be shown. That's all right. Maybe I'll remember next. Remember to give if you can. That's cool. I hope you enjoyed the show. We had a pretty good chat there. Me and Shockwave, and Andy was there, and Neil, and a little bit of Paulie that we got. We're going to be doing it again real soon. Usually on Friday mornings, we have our little talks. We're going to be, I think, you know, maybe exploring that a little bit, doing a live stream in the morning. So, just want to see who we got. Raycar, what's up, Ray? Al4, leave it 79. I know you, it's Frank. Melanie Stockfeld. Damn, just joined. Glad you're sticking around. Yeah, that's something I figured to do a little bit more often. Tim Healy, good to meet you. Comment, pause this universe. Come on. Pause. Yeah, first. That's something. With the comment symbol. That's funny. I didn't even think about that ever before. Modern Maniac. Good to see you. I hope Bell's probably gone. It's good to see you. Bob John. Yeah, X-ray laser is a deadly weapon. It's actually what Tesla's death rate was. An X-ray laser. They perfected it in the 60s, 70s. Sometime, no, I think it might not have been to the Reagan era, but they had a breakthrough. And that's where they got all real tight-lipped about it, and, you know, ended up winning the Cold War. But anyways, you know, I always hate to leave. You know, I like to spend time with you. A lot of times, you know, we'll be talking about what's on our mind, but I'd like to kind of monitor chat too, because you guys have a lot to, you know, interject into the conversation. I'm not saying that, I mean it. You know, when I go into chat rooms, I see that all the time, but you guys are extra smart, so that's what I enjoy, you know, stimulates the conversation. So we're going to try to incorporate that a little bit more and have some more live talks. I don't have a lot of live talks, but we're going to change that. Yeah. And of course, I got to get back to making videos. I got one in progress. It's just going real slow because I keep working on everything else before. But everything else is going good. I'm kind of sad, you know. Summertime is coming to an end. My daughter's going to be leaving for school. You know, I'm the emotional one. It'll be like daddy that cries, not mom. It's just the way I am.
about her. Crazy. If you had daughters. Because my son, I'm like, yeah, my daughter is a special spot there. Something pretty cool. She's going to be going to college. Pretty proud. Going to miss her though. So, well, we still got 42 viewers. Maybe I try to blink in one more program for you because I know I'm not going to fall asleep just yet. Jeopardy. Oh gosh, I know. Every time I see Frank, I cringe because I know he's waiting. He's been cool about it too. I wrote it twice, and twice it got zapped because my computer was all messed up. Got things straightened out finally, so I got to start all over again. That's the truth of it. But I will. I had all of it written too, right? I had Electric Universe and Saturn Theory finished. I had to just make a couple more categories, and got the blue screen of death, and then I had to do a bunch of shit. I didn't think I was going to come back, but I did. Now everything's cool. So, all right, I'm going to play another video. A little bit more of, I don't know. You guys, I don't know what I'm in a mood for. Hold on, let me look. For those of you that don't know, when you go to my homepage, that's like right here, I have, for you, and then categories of my videos. That's all the videos I've uploaded, live streams. They're some of my more favorite ones. And Worlds of Collision, of course. So a lot more stuff here too. So if you ever want to get to my homepage, take a look at it. It was there. So let's get into one video here. I don't want it to be in the subject matter. Got to play this. Well, I got a good one about the similarities between JFK and the Trump attempt, but it's not quite finished. Damn it. Or I would play that. But it's kind of out of context. So, let me see. Just grab one. It's easier said than done. What I got. All right, we'll do this. That's too long. I wanted to do a little JFK thing, but I don't have that video finished. Go back. Sorry. I should have it together more. Lives tonight. Let's see. I want something that's not new, that's not old. You haven't seen before. Oh, right here, we were talking about. Okay, so we'll check this out, and that'll be it. Thanks for putting up with me, folks. I love you.
Scientists discover an energetic cosmic serpent in our galaxy. In ancient Egyptian mythology, Apep was the serpent god of darkness, destruction, and chaos. In contemporary astronomy, Apep is the nickname for a massive, just-discovered star system surrounded by serpentine dust swirls and officially known as 2XMMJ 160050.7-514245. They just have a way with names. It is believed to be the only such star system of its kind in our galaxy, and it's destined for destruction. We never expected to find such a system in our own backyard. Joseph Kellingham of the Netherlands Institute for Radio Astronomy said in a statement, Kellingham is the author of the study unveiling this discovery published today, November 19th, in Nature Astronomy. Like its namesake, the mythological god of Yore, Y-O-R-E, who was blamed for solar eclipses and said to battle the sun god Ra every night. I thought that was Set. The cosmic serpent Apep is a sign of a very powerful force. Scientists believe that the star system is made up of a binary star system and a single star, which are rotating around each other, held together by electricity. The rotating stars in this system are called Wolf-Rayet stars. They are dying very slowly and will likely end their lives with a gamma ray burst, one of the most energetic, explosive forces in the universe. Long-duration gamma ray bursts. Before their end, Wolf-Rayets release powerful stellar winds that hurl out matter at millions of miles per hour. In this system, stellar winds were measured to travel at nearly 7.5 million miles, 12 million kilometers an hour. The dust created by these winds moves much more slowly, swirling like a pinwheel around the connected star system. The scientists believe one of the stars, about 8,000 light-years from Earth, is the first known candidate in the Milky Way to produce a dangerous gamma-ray burst, among one of the most energetic events in the universe. When it explodes and dies, the system, comprising a pair of scorchingly luminous stars, one star is on the brink of a massive supernova explosion. Findings published in Nature Astronomy are controversial, as no gamma-ray burst has ever been detected within our galaxy. Yet in the southern constellation of Norma, nestled beneath the Scorpion's tail, astronomers have discovered this unique star system. At its heart, wrapped in an elegantly sculpted dust and gas, lies a powerful binary pair. The two hot, luminous stars known to astronomers as Wolf-Rayets orbit each other every 100 years or so, according to research conducted at Sydney Institute for Astronomy. This orbital dance is embossed on a fast wind streaming off the stars using spectroscopy. Astronomers have measured the velocity of the stellar winds, fast at 12 million kilometers per hour, or 1% the speed of light. The rapid wind and strong magnetic field of the pulsar have generated a wind of energetic matter and antimatter, particles that flow away from the pulsar near the speed of light. This pulsar wind has created a highly magnetized bubble of high-energy particles called a pulsar wind nebula, seen as the blue region surrounding the pulsar. The high speed may be due to the pulsar wind nebula expanding into relatively low-density environments. Unlike other supernova remnants from this era, the brightness of this pulsar wind nebula has decreased 10% from 2000, and it poses no threat to Earth. Wind pulsar nebula, first I've ever heard of it. And it also says that as well as its unusual structure, the rapid changes observed in KES 75 pulsar wind nebula, that's a new one, as well as its unusual structure point to the need for more sophisticated models of the evolution of pulsar wind nebulas. Enigmatic neutron star. More sophisticated models, that means more funding. It's insane. That's the serpentine swirl dubbed Apep. I remember watching a cosmology show a few years ago where they were exploring the hypothesis of a supernova striking the Earth and blowing our atmosphere completely off the planet in one fell swoop. And everyone on Earth would be, everyone would be out of here. That would be it.
Get to the chopper!
does the electric universe have to say about Wolf-Rayet stars, or Wolf-Rayet stars? And it is spherical shells around stars are signs of electrical activity. More than 70 years ago, Dr. Charles Bruce noted that planetary nebulae are similar to electric discharges. He reasoned that their shapes were hourglasses, with central stars obscured by dusty toroids. Since nebular shapes are similar to the twisted filaments and spirals of electric discharges, they also appear as near spherical shapes. A recent press release states that a bubble-like structure is wrapped around Wolf-Rayet star SH2-308, or Easy Canis Majoris, in the constellation Canis Major. As the announcement says, ongoing radiation from the star pushes the bubble out further and farther, blowing it bigger and bigger, some 60 light-years apart. Electric discharges in plasma form double layers along their current axis. Positive charges build up on one side of the cloud, negative charges on the other. A powerful electric field develops between them, and if enough charge is applied, the double layer glows. Otherwise, it remains in dark mode and is invisible. In plasma, the electric charges spiral into filaments, which attract each other, sometimes pinching into arc mode discharges. As written many times, double layers can be pumped with energy from galactic Birkeland currents. Increased flux density draws matter from surrounding space into filaments, igniting nebular gases electrically. Could this be what is reported by the European Space Agency? Unfortunately, at this point in time, the only way to detect double layers in space is to send a spacecraft equipped with a Langmuir probe through them. Local experiments within the solar system detect double layers like those created in the laboratory. Such structures are known as magnetospheres, magnetotails, cometary nuclei, and comet tails. In 1981, Nobel laureate Hans L. Fain wrote, "It is unpleasant to base far-fetched conclusions on the existence of a structure which we cannot detect directly, but the alternative is to draw far-reaching conclusions from the assumption that in distant regions the plasmas have properties which are drastically different from what they are in our own neighborhood. This is obviously far more unpleasant. Filaments, braids, overlapping rings, stacked rings around the central star, hourglass shapes and coherent tubes of filaments are visible around SH2-308, and I'd probably say around APAP too. In an electric universe, it is not hot gas that flows through space, it is plasma. The physics of electricity apply, not the physics of wind. Inside the shells of planetary nebulae are more and more plasma sheaths that act like capacitors, alternately storing and releasing electric energy. Electric currents ebbs and flows inside and outside sheaths within the shells. The Hubble Space Telescope's image reveals many of plasma's fundamental glow mode characteristics. Since the central star's axis is a Z-pinch funnel, the cylinder of electric current appears to be a circle or bubble. Nebulae are stellar Z-pinches in a flow of electricity, so there is enough power to supply the radiation load of current of the central star. Stars, as written many times elsewhere, are powered by electricity coupled with nebular discharge currents rather than nuclear fusion. Since nebular currents cannot exist beyond their optical glows, they must be part of completed circuits that wind through the Milky Way. Dying stars and elements formed in supernovae explosions. Primordial hydrogen and helium make up 98% of its overall mass. With a process of continuous creation in its core, thermonuclear fusion reactions are thought to produce heavier elements there. Heliophysicists think that the sun is a gravity engine, deriving all of its power from mechanical compression. It is called thermonuclear fusion because dust clouds collapse. Energy is thought to occur when gas and dust clouds collapse, forcing hydrogen atoms together in a gravitational vice. The result is supposed to be the formation of helium atoms and the release of energetic particles that can take 1 million years to travel outward from the solar core. Acoustical waveguides then carry hot gas from inside the sun on a conveyor system that depends on convection and shock waves. The fact that kinetic energy dominates astronomical theories is illustrated by a recent press release from the National Astronomical Observatory of Japan. The Hinode spacecraft, in orbit around the sun, observed the strongest magnetic field ever directly measured on the surface of the sun. However, the bias toward mechanical action is obvious when they announce that the field is due to gas outflow from one sunspot pushing against another sunspot. Wait a minute, did it just say the Japanese are in a spacecraft? Oh, they have a probe. What are they doing? Buzzing around the solar system? Big red ball on the side. Yeah, same old. They're not allowed to think. They've got to know better. I mean, a lot of them probably, but they just play the game, but they don't get paid. Consensus schools of thought do not accept electric universe theory, viewing the sun as an anode or positively charged terminal with an electric double layer isolating it from charged particles traveling through the galaxy. Suggests that the sun experiences charge-discharge phenomena inside its heliosphere. Therefore, it is the sun's capacitive, resistive, and inductive aspects that drive its activity. Yes, indeed. Did you know that when you get an X-ray, that inside that X-ray machine is nothing more than an anode and a cathode? It's electrically driven, just like nuclear explosions. They short out the electrostatic field of the Earth. An electric sun means that electric discharges penetrate its photosphere, allowing electric charge to flow into its depths. It is electromagnetic flux tubes, rather than acoustical waveguides, that expose the sun's cooler interior. Those flux tubes connect the sun's electromagnetic environment with other nearby charged bodies, planets, moons, comets, etc. Electric fields in space accelerate charged solar particles, creating coherent electric networks that flow through the solar system. In an electric universe, celestial bodies are immersed in plasma and interact along circuits. Since the sun is electrically interconnected with the Milky Way, it should be thought of as a charged object seeking equilibrium with its environment. Since the balance is not stable, electric charge flowing into and out of the sun can sometimes cause tremendous bursts of energy called solar flares. A positive space charge sheath exists with respect to the interstellar medium, ISM, so sunspots and flares result from variations in electrical conditions. The sun appears to experience cyclic influences. 25 August 2020 was captured when the planet was 653 million kilometers from Earth. Hubble's sharp view is giving researchers an updated weather report on the monster planet's turbulent atmosphere, including a remarkable new storm brewing and a cousin of the Great Red Spot changing color again. The new image also features Jupiter's icy moon Europa, but no dolphins. It is a beautiful planet. Electrical charged superfluid plasma cosmology has a Living Galaxy Cell Theory essay here, so I can't help myself. I have to check it out. That's pretty interesting. The living mitochondria cells mimic galaxies of the cosmic web filaments, plasma membranes, analog relativity. Nuclear membrane of a pig kidney. The cytoskeleton underlies the plasma membrane throughout the inside of the cell. All cells have a cytoskeleton protein mosaic just beneath the cell that determines the shape of the entire cell. Stars fill the interstellar medium, ISM, with complex organic, the inside or plasma of a galaxy, which interacts with carbon nanotube, forming the protein mosaic membrane skeleton surrounding inside the membrane of a galaxy. A living galaxy cell surrounded by life in the intergalactic medium. The cytoskeleton is shaped like a galaxy at different views. Very interesting. I've always wondered, the inside of a person is much like the universe. Plasma red blood cell hologram analogy of a living cell galaxy. The ancient Egyptians also equated the universe with the human body. Stars are factories that produce and eject huge amounts of detectable complex organic molecules into the interstellar medium everywhere inside the galaxy. Amino acids self-assemble into proteins and DNA inside carbon nanotubes. In outer space, life might exist in outer space. Conditions showed Johnson organic nanotubes self-assemble into functional, cellular, macroscopic membranes. 3D and 4D life might exist in outer space at quantum and cosmic scales, still unknown and undetected. Many times in my muses of nebula, I am so attracted to the nebulas that look like works of art with actual beings, humanoid type. And what I always wondered and mused about is the nebula that we're looking at a mirror into a grander universe, our microcosm world? It's amazing, it really is. And I would, if I had to bet, I would say that we're definitely linked all the way up and all the way down into this magic universe. Life might, that's interesting that he says that. Plasma blobs form a two-layer plasma membrane with an inner nucleus of gas atoms. Complex self-organizing plasma structures exhibit all necessary properties to qualify as living inorganic matter. Complex plasmas easily form naturally in galaxy, in outer space conditions, into helical organic structures. Complex plasma mimics the functions of a living cell. A galaxy is 99.9% plasma. NASA Space Center scientist Dennis Gallagher states that 99.9% of the universe is plasma. Complex plasmas behave like a liquid in very small amounts. Just a few thousand of micron-sized particles that fractally scales to nanometer water size. Star clusters are organized by ISM, interstellar medium, organics, having polarity-driven electromagnetic interactions with incredibly dynamic common single-atom thick carbon nanotubes, buckyballs, graphenes, coupling of the nanoscale to the macroscopic proteins. Did you read the thing on the carbon stars that I had at the end of the sun video? Pause it and read it. It's very interesting along the same lines. Dynamically transforming proteins like actin assembles from only 10 amino acids supplied by common stellar ejections into the ISM, which would self-assemble actin under interstellar space conditions. Actin microtubules are 7 nanometers in diameter and naturally forms double helix structures. The cytoskeleton protein mosaic is mostly actin that shapes entire cells, galaxies, and the entire cellular cosmic web. Individual star clusters inside galaxies look exactly like the locations of single individual molecules that comprise actin filaments everywhere throughout a living cell. Star cluster NGC 3603 is only 20,000 light-years away. Detectable 10-year changes in star locations defy gravity theories, showing all stars move nearly the same speed. Actin's stable space cable. Actin microfilaments are 7 nanometers in diameter and, amazingly, are the same diameter required for macroscopic scale friction-free high-speed fluid movements inside carbon nanotubes that power multiple cellular processes, such as motility and polarity. Individual actin filaments are briefly built and broken randomly, but collectively they line up side by side and form breakage-resistant cables, shows Michelot. Proteins dynamically transform their structures into constituently similar amino acids. 10 major amino acids comprise actin, which is 50% of the dry mass of the cell. 50% of the dry mass of the cell. Actin is nearly the same in all species, and is the thinnest, most common, strongest, stablest, most tensile, flexible filament in all known life forms. Microfilaments, mostly actin, are everywhere in the cell, as solid rods made of globular proteins of actin nanotubes. Abundant, complex organic molecules in the interstellar medium would comprise a space metamaterial fabric composed of a transparent cytoplasmic gel connecting entirely the inside of a galaxy, except the nucleus. These same living processes that occur inside cells by the dimensionality of carbon manifest and organize macroscopic cosmological phenomena, such as bifractal scaling, magnetic reconnection. Oh, okay. These guys, they must be a little bit different than the Thunderbolts folks, because they don't magnetic reconnection. Don Scott does not like that. Carbon nanotubes enter the cell nucleus of cells naturally without harmful effects. The cell nucleus undergoes division and polarity, arises when electricity flows through carbon nanotubes. This would cause the nucleus to spin like a black hole of a living galaxy cell. This might be some new folks on the scene. I have not seen any of this stuff before. It looks really good. It's going to be interesting reading a lot of it. The title grabbed my attention. I thought I'd bring it to you. Lots of new stuff coming our way from the electric universe. The next decade is going to be very interesting indeed. The more data that pours in, the harder it's going to be to plug those holes. The Kina Cowie KBC void, named after the Wisconsin astronomers Kina, Barger, and Lennox Cowie, is thought to be one of many. There is no emptiness in the electric universe. According to a recent press release, astronomers are puzzled by the extent, as well as its lack of galaxies in what is deemed the largest void yet discovered. Void is approximately 2 billion light-years in diameter, as astronomers measure distance, and it's within that cosmic bubble that the Milky Way galaxy is said to reside. The problem is, such a structure should not exist.
The other one said 6 to 8 billion.
Contains far too little matter for its size. The universe is theorized to be a certain age. As the scientific consensus thinks, all matter and all energy came into being during the Big Bang. Based on its theoretical expansion rate, the universe should create various formations for time. The problem with the empty regions, like the KBC, is that gravity has not had enough time to pull matter into bounded bubbles with empty centers. About 15 years ago, astronomers discovered that remote galaxies seem to indicate the universe is expanding. faster today than it did in the past.
That's
Such anomalous redshift observations threaten Big Bang cosmology.
versus static.
So the existence of negative pressure on gravitational fields was proposed. Negative gravity ideas flew in the face of most theories. So the accelerated expansion was later amended to dark energy. Because it cannot be detected with any instrument, only inferred. Instead of accepting that observational anomalies exist because the Big Bang theory is faulty, astronomers resort to theoretical addenda, such as the questionable idea that space can be pulled, twisted, or stretched. In a previous picture of the day, astrophysicists from the University of California were quoted as saying, "The universe is made mostly of dark matter and dark energy, and we don't know what either of them is." From the perspective of electric universe theory, it is electricity that drives galaxies and their associated stars. Laboratory experiments confirmed that Birkeland current filaments form structures that resemble spiral galaxies. Birkeland currents have a longer range attractive force than gravity by several orders of magnitude, diminishing with the square root of the distance from their current axis. That powerful electromagnetic attraction could also account for the movement of stars near the Milky Way's core, as well as the acceleration of galaxies in deep space. Birkeland currents are the strongest long-range attractors in the universe. A physicist and electric universe pioneer, Hans Alfvén, said, "I have never thought that you could obtain the extremely clumpy, heterogeneous universe we have today, strongly affected by plasma processes, from the smooth, homogeneous one of the Big Bang, dominated by gravitation." From A.L. Peratt, Dean of the Plasma Dissidents, Washington Times, Supplement The World and I, May 1988. Stephen Smith.
Oh yes, quite profound. We have a little way to go still. I hope you're enjoying the night.
Close encounters of the starry kind. Red dwarf passed within 0.8 light years of our solar system. Now that's getting pretty close to what we're talking about. Shoal's star was discovered in 2014 but appeared to have an odd motion. Astronomers traced its path through the sky and found it was moving away. They found it came closer than any known star 70,000 years ago. It passed so close that it passed through the outer Oort cloud, which is a theory of comets. Our current nearest star is Proxima Centauri, around 4.2 light years away. It's another red dwarf. The Shoal star came 5 times closer, but it is now 20 light years away. Our solar system had a close encounter with another star 70,000 years ago, research has revealed. So we're not that far off after all. The recently discovered star passed just 0.8 light years away. They're not really given much else on it. Astronomers discovered the star's flyby by tracing its movement through the sky and found it would have passed within the outer Oort cloud of comets. Dr. Eric Mamajek, an astronomer at the University of Rochester who led the study, said that it is unlikely the star would have caused much disturbance to the scattered icy comets that orbit the outermost reaches of the solar system. However, he said it raised the possibility that other close encounters with stars in the future could have far greater impact. He said, using that, I like the way they use the word impact. They want to make you think of it crashing into us. He said, using the best available astrometry, our simulations suggest the probability that the star penetrated the outer Oort cloud is 98%. While the flyby of this system likely caused negligible impact on the flux of long-period comets, the recent discovery of this binary highlights the dynamically important Oort cloud perturbers may be lurking among nearby stars. Schultz star was first discovered in 2014 by Rafe Dieter Schultz. Of course, I know nothing, I see nothing. But unlike other stars around it, it appeared to have an unusual motion in the sky. A team of scientists from the US, Europe, Chile, and South Africa used observations of its motion to trace back its trajectory. They found that the star is moving away from the Earth at great speed and came alarmingly close 70,000 years ago. They calculated that the star, which also has the catchy name WISE J 072003.20084651.2, passed 5 trillion miles away from our sun, 0.8 light years away. So that'd be a load of dust 0.8 miles from the sun. I don't think it would have much of an effect. But seeing that they're saying that it can get that close, it's not far off from one entering the sun's heliosphere. This close, it would have been impossible to see the star from Earth with the naked eye. It was far too dim. Scientists believe it is an active red dwarf that is about 8% the mass of our own sun. It is part of a binary system and is accompanied by a brown dwarf, a failed star that was too small to spark life, even when at its closest to Earth. Schultz star should have been 50 times bigger than what can be normally seen with the naked eye. Instead, the star would have been visible with a telescope, technology far beyond our ancestors 70,000 years ago. Says them. However, the star may have occasionally flared and become brighter for a few minutes. For any of our ancestors who glanced upwards during such a flare, they would have seen it in an area around the Big Dipper. Astronomers who work published in the Journal of Astrophysics Journal Letters calculated that Schultz star's path would have taken it through the outer areas of the Oort cloud. And they have a little diagram of the hypothesized Oort cloud. This is where they believe long-period comets come from, and short-period comets come from the Kuiper belt. This is what they say, mainstream. It's always good hanging out with you. Always hate leaving. It's good to be that time. Even if I was monetized, my videos are way too long. Doing good?
Now kick back and relax and enjoy the next few hours.
One instance of the Saturn myth that can be verified with the help of a small telescope: Saturn is in chains. Instead of solving anything, this fact has created a problem. It demands a solution. How did the ancient Greeks and Romans know that Saturn is encircled by rings? It is strange that this question was not asked before. The existence of these rings around Saturn became known in modern times only in the 17th century, after the telescope was invented. They were first seen, but misunderstood by Galileo and understood by Huygens. If the myth did not by mere chance invent these rings, the Greeks must have seen them. The last case could be true if the Greeks or some other Oriental people possessed lenses adapted for the observation of celestial bodies, or if the rings around Saturn were visible to the naked eye at some time in the past. Today they are not visible without magnifying instruments. There are cases of exact observations by the Chaldeans which suggest the use of some accurate technical means. These means could consist of a sort of astrolabe like that of Tycho de Brahe, who made most accurate observations of celestial bodies without the help of a telescope. Also, Copernicus, prior to Tycho de Brahe, made all his calculations of the movements of the planets before the telescope was invented, but neither Tycho de Brahe nor Copernicus saw the rings. The statue of Saturn on the Roman Capitol had bands around its feet, and Macrobius, in the 5th century of our era, already ignorant of the meaning of these bands, asked, "But why is the god Saturn in chains?" In the Egyptian legend, Isis, Jupiter, swathes Osiris, Saturn. The Egyptian appellative for Osiris was the swath. In the Zendavesta, it is said that the star Thistria, Jupiter, later Venus, keeps Perico in twofold bonds. Saturn is encircled by two groups of rings, one larger and one smaller, with a space in between. To see this, a better telescope than that used by Galileo Galilei or that used by Huygens is needed. The twofold structure of the girdle was first observed in 1675. The rings of Saturn were known also to the Aborigines of America before Columbus discovered the land. This means also before the telescope was invented at the beginning of the 17th century. An ancient engraved wooden panel from Mexico shows the family of planets. One of them is Saturn, easily recognizable by its ring. Nor were the Maoris of New Zealand ignorant of it. One of the great mysteries connected with Saturn is the still unanswered question of how the ancient Maoris of New Zealand knew about her rings, for there is evidence that they did have a Saturnian ring legend long before the days of Galileo. In the myth, it is said that Jupiter drove Saturn away, and that on this occasion Saturn was put in chains. If these words mean what they say, and are not a meaningless portion of the myths, in a dream at least there are no meaningless parts, then the knowledge of the ancients about the rings of Saturn could have been acquired because of better visibility. In other words, at some time in the past, Saturn and Earth appear to have been closer to one another. Originally, I assumed that the rings of Saturn may consist of water in the form of ice. But since the ancient lore all around the world tells that it was Jupiter that put these rings around Saturn, I considered that they might have some other components too. Since the 1960s spectroscopic study of the Saturnian rings has confirmed that they consist mostly of water in the form of ice. The rings of Saturn are referred to by Aeschylus Eumenides 641. He, Zeus, himself cast into bonds his aged father Kronos. Moreover, it is not true, neither, that Saturn is enchained. Neoplatonists like Proclus and Timaeo by Festagirad sought a philosophical or mystical meaning in the tradition also, and yet the king of the gods, the first and eldest one, is in bonds, and they say, if we are to believe Hesiod and Homer and the other wise men who tell this tale about Kronos. Augustine, refuting those who asserted that the Jewish Sabbath was held in honor of Saturn, wrote a bunch of stuff in Latin.
Iter patres nostri longe fuerunt a Saturnices patinas, quam vis pro tempore profiatio subarti vacation mortive everent.
Contrafaust Manicum XX 13.
These chains with their double fetter, Zerlius dedicates to you, Saturnus.
You don't make up for your sins in the church. You do it in the streets. You do it at home. The rest is bullshit.
The shrines to Saturn in Roman Africa portrayed the god with his head surrounded by a veil that falls on each of his shoulders in a way reminiscent to the planet's rings. Ancient knowledge of Jupiter's bands and Saturn's rings. Classical Journal. Yeah. And then we got ancient knowledge of Jupiter's bands and Saturn's rings. Kronos 2-3, 1977. When Galileo first saw the rings in July of 1610, he thought them to be two satellites on either side of Saturn. And this is what he also announced in his Sidereus Nuncius. The planet Saturn, A. Alexander, 1962. Huygens, Systema Saturnium, 1659. Saturn too is represented with his feet bound together, and although Furius Flaccus says that he does not know the reason, Apollodorus says that throughout the year Saturn is bound with a bond of wool that is set free on the day of his festival. The Osiris cult and the designation of Osiris idols in the Bible. The Zend Vesta, Tristria, the bright star, keeps Periaiko in twofold bonds, in threefold bonds. A third ring around Saturn was observed in 1980. Velikovsky also thought that mythic representations of Kronos, with his body encircled by a snake, may attest to a memory of the rings of Saturn. The planet Saturn, shown in an ancient woodcut reproduced in F. Maurice, London, 1800, Volume 7, and described by the author as encircled with a ring formed of serpents. Tammuz, who represented the planet Saturn in Babylonia, was called He Who Is Bound. Ninib, who was also Saturn, was said to hold the unbreakable bond. The observation was made by G.D. Cassini. Regarding the process of formation of Saturn's rings, Velikovsky thought it might have been analogous to the formation of a disk-like ring of gaseous material around some stars in binary systems, as described by H. Friedman in Science 181. Gas enters into Keplerian orbits and accumulates in a disk somewhat resembling Saturn's rings. In August 1965, Tobias Owen, writing in Science, reported that the reflection spectrum from the ice block gave the best match to the absorption observed in Saturn's rings, but that the most likely alternatives would be ices of methane and ammonia, both known ingredients of the Jovian atmosphere, methane being also in the composition of the Saturnian cloud envelope. As early as 1947, Kuiper, The Atmospheres of the Earth and Planets, 1949, concluded on the basis of spectral measurements in the infrared that the rings are covered in frost, if not composed of ice. Saturn's rings, although H2O is a major constituent, the spectra reflectivity indicates the presence of other materials. Into a time before the coming of the planet Saturn. Astronomers had long been aware that there would be an alignment of the planets on March 10, 1982, where Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto would be on the same side of the Sun, within an arc 95 degrees wide. But no effect could be expected, as the tidal forces of the other planets affecting the Earth's crust are negligible, even at the planet's closest approach. In the book The Jupiter Effect, the authors sought to partially sidestep objections by considering the effect of the alignment on the Sun, and hence on the solar wind, which in turn is known to affect weather on the Earth. Atmospheric conditions on Earth can alter the speed of its rotation. The effect on the Sun would also be quite small. However, and in fact, there had been an even closer alignment in the year 1128 without any incident. There was some influence by the planets mentioned above, with the high tides calculated as being about 40 micrometers higher than normal. In April 1982, Gribben and Plagman published a lesser-selling book, The Jupiter Effect Reconsidered. In it, they theorized that the effect had actually taken place in 1980, despite the lack of planetary alignment then, and that it had triggered the volcanic eruption of Mount St. Helens. The 10 notable apocalypses that obviously didn't happen. In 1974, John Gribben and Stephen Plagman wrote a best-selling book, The Jupiter Effect, but there was that third ring on Saturn in 1980. The arrival of the waters. Following the 7 days, when the world appeared to be ablaze in the radiance of 1,000 suns, the deluge started. First, according to the Hindu account, vast clouds gathered which overshadowed the entire world. These ominous clouds, rumbling, shooting lightning, overspread the sky. They were as vast mountains. Some were dusky, some crimson, some white, some brilliant in hue. Other sources describe them as yellow or azure or red. Loud and roar and mighty in size, they fill the entire sky. They were friends with lightning and meteors and thunderbolts. Then, rumbling aloud with lights, they poured torrential streams, thick like chariot wheels. They rained with a sullen roar, inundating the three worlds, ceaseless downpour of torrents. And then there were seen on all sides the four oceans, engulfing with tempestuous waves the whole surface of the earth. All creation was smit by the luminous, dense floods. In the beginning of the deluge, the nova in the sky shone through the splendor of the illuminated skies and through the sheets of rain, ever increasing in intensity. The biblical expression, "the Lord sitteth upon the flood," was an apt description of the blazing nova above the waters of the deluge. It has a Babylonian counterpart in the title of Tammuz, as Bel-Gersu, Lord of the Flood. The nova blazed terrifically, but soon the light became diffused. The shadows grew ever dimmer. The world that was all splendor and light turned gloomier and gloomier. The outpouring waters grew ever thicker. The clouds of dust darkened ever more the sky. And finally, the drama that was taking place on earth went on in darkness. The deluge was not a peaceful, though abundant rain, filling the earth with water. rising ever higher. Ancient sources give a description of the deluge that differs greatly from the pageant of showers pouring from above on peaceful land and peaceful sea.
Skandapurana in S. Shastri.
The flood legend in Sanskrit literature, the Babylon expression in the wailings for Tammuz, the shining ocean to thy perditions has taken thee. Babylonian Liturgies, Paris, 1913.
Thank you for coming, everybody. I really do appreciate it, coming hanging out with me. And we'll do it again next week. I'm going to start building the show right away. And we're going to have some good stuff to talk about. Just reading Ray Carr, you watch Dark Journalist? Yeah, I watched that show with Pharrell. I thought it was pretty good. Yeah. I like Pharrell has a good mind. You know, he thinks differently than people. Who played that little guitar solo a little bit ago on the video? I kept rewinding it over and over because I like it so much. Are you still here, Jessica? I hope you're still here. Well, I'll tell you what. I think I might know what song that was, but I gotta remember what folder it's in. That might be a toughie. Not in this one. I have so many folders, I don't know what to do with them all. They all bleed together after a while. What folder was I pulling from for this video? Oh my goodness. Box music? No. Oh, that's too bad. I wish I knew. It might have been called Dirty Blues. I knew it would come to me. Let's see if I have it. Dirty Blues. Man, I wouldn't even know where it is. I just happened to look in that folder and wow, it was a good song. We'll just go to good old music and see what happens. I don't have one. You'd think I would. Mixes? I doubt it. No. I wouldn't have the slightest idea to know what folder. Well, what I should do is just say goodnight, and if I feel so inclined and I'm still awake, maybe I'll come back. And you guys have been really great. Thank you so much for tuning in. Yes, backup PC work. I got a bad out drive. That reminds me. My out drive with all of my work on it is no longer communicating with my computer. I don't know why, it just stopped. And I gotta somehow get all that work taken off of there and put on somewhere else so that I don't lose it, because otherwise I'm gonna have to re-download every single video I've ever uploaded. I want to keep them and a brand new out drive. I mean, if out drives break, then why even have them? It's ridiculous. I'm not paying for storage. Screw that. I'm gonna pay for everything. Ah, boy. What a mess, huh? The way the world is today. Crazy. I mean, it's just crazy. It's upside down. Well, guys, I guess I'll say goodnight. I do enjoy talking to you. Got to do that really more often. Hi, Jess. Great car. Melanie. Good to see you. Universe within a universe. Perhaps our observable universe. Microcosm. You know, that's what I was saying. You know, what if those giant nebulas in space are just creatures moving around in a far grander universe, but they're so big they just look like big splotches to us. Something. You know, it's just something I mused over once. A few times, actually. And it could be a never-ending chain. All the way up, all the way down. How would you know? I mean, how do they know what size to make us? How did that take place? Do you think there are planets where people are 100 feet tall? I think it's possible. A lot of what ifs, you know, but that's what keeps us going. We have like to know answers. What if on JFK issue, Lee Harvey Oswald was JFK's communication link with Russia? What, you know, that isn't the first time I've heard that. That's been speculated by very many people that are in the know with that whole thing. And that he actually was working for Bobby Kennedy when he was in New Orleans, being sheep-dipped as a communist for that one idiot that worked, you know, in the upstairs place. I can't remember what his name was, the FBI agent, the gun runner, you know. But, you know, they were just making him look left. All of his friends were all on the right. But he was, a lot of people said that when Bobby Kennedy saw Lee Harvey Oswald's name on the list, that he knew immediately who he was affiliated with, ONI. So he called up the CIA and said, one of your guys did it. So, and I don't think he was talking about Lee Harvey Oswald, because the reason why they double-crossed him and set him up like that was because a couple of weeks earlier, he fingered the secret camps for the FBI to bust. Took all their C4 and all that. Really pissed him off. It was an ongoing battle there. But anyways, yeah, I like talking about JFK. That was the first thing I grew up with, you know. Been studying that for years and years and years. Not just his death, life, his presidency. He was a very unique man of highest integrity. Dude, truth is number one. And sulfur less than truth. I agree with that. Well, guys, I had a great time. We're going to be making another one of these videos in I'm going to make that JFK video and release it as soon as I can. And the similarities between JFK and Trump, assassination attempt. And otherwise, I'll see you next week. Thank you so much for tuning in. Love you. Please like, share, comment, and do donate if you can. We're struggling over here at this little fledgling channel. Bye-bye. God bless.